Assalamu alaikum, ladies and gentlemen, welcome back to another live stream. So this is my second stream on rewriting my Vulkan C++ engine in Rust using ash binding. Alright, so please join my Discord server. You can find the link down in the description below. It's just discord.kodotaku.com. Otherwise, let me actually notify people there real quick. How do I pin this? I don't know. Either way, let's go to Kodotaku. And there we go. Alright. Now let's just grab the chat here, pop out the chat, and let's go. Okay, so last stream we just had two windows that are being rendered using Vulkan in Rust, of course, and of course using Winit too. And one of them is cleared with the red color and the other is green color, nothing crazy. And that's pretty much it. Now, first of all, we're gonna start off by basically making this perfect, because there's a lot of rough edges right here that I've ignored, so we could you know, get something working on the screen really quick. But other than that, I need to make sure that the live is fine, and then we could start. Yeah, seems good to me. Alright, so let's just get going. Alright, so first of all, I'm gonna actually remove this window 1, window 2 options like this. We're gonna make it into one hash map of windows. In fact, we have a lot of problems here. First of all, this redraw requested, you can notice here that this window ID is not being used. So redraw requested basically tells you which window actually wants redrawing. Here we're currently just redrawing both windows whenever any of them request redrawing, which of course is not great. So here's how we could do it. Well, we're gonna remove this stuff, and instead we're gonna say Windows is basically a hash map of window ID, right, and window. And for our renders, what we're gonna have instead of this, we're gonna have the same thing. Renders is a hash map of window ID render. So both have the same key of window ID essentially. So that's great. The other thing that you gotta pay attention to is ownership. So in C++, things get destroyed in reverse. So like renders get destroyed first, then GPU, then Windows, right? But here in Rust, the destruction order is like the same as the order of the struct. So it's reverse, right? So here the Windows would get destroyed first, then the GPU, then the renders, which is not great, right? So I guess the first thing we want is maybe the Windows, and then the GPU, then finally the renders, and that's basically how it goes. Now let's actually change this a bit. Let's say right now, let's just make one render for now. We could, or honestly, fine, let's do this. So let's see what we got here. Honestly, let's just rewrite this, I think. Or fine, so yeah, fine, let's rewrite this. So it's gonna be cleaner. Alright. So the first thing we want is a GPU, right? So arc new, GPU, new event loop. And we're gonna say self.gpu is equal to some gpu.clone. Huh. Can't we just say GPU new event loop in wrap? Okay, that's good. Next up, we're gonna create a window, which is gonna have default window attributes. Though of course you don't create a window like this. Use the event loop. Oh my god, this AI sucks. Anyways, so create window, and then we need the window attributes default here. And let's see what we got next. So here is just the result, I believe. Well, actually, we'll just say in wrap here. All right, so this is the first window, and we gotta create a render for it, right? So render 1 is equal to render new, right? So this is our primary window essentially. How? Hello, Polisovanal. Welcome to live stream. Alright, so let's see what we're doing here. So we're creating a window with default attributes, and we're creating a render, and this should take this window right here, and the extent here needs basically window dot inner size dot into, because this takes an array currently. Well, I believe so. Actually, it doesn't. So let's actually change that real quick. Instead of its extend 2D, let's just take an array here, I believe. Is it like this or what? That's weird. U32, 2. Okay, and then let's change this here. vk extend 2D, default dot width, extend 0, extend 1 there. And apparently, I see. Alright, fine. So that's good. Now we got the render, we're gonna unwrap it. And next, so here we're gonna grab the ID of the window, window.id, and then we're gonna insert it into the hash map. And we're also gonna insert the render with the same ID of the window, just like that. So we got the window, we got the render, here we got the GPU, of course. And yeah. So that's great, but hold on. Honestly, you know what? Let's just do GPU here, really. Yeah, fine. Alright, that's great. What's next? Now here, instead of this business, what we're gonna do actually, we're gonna check out if we have a render using that specific window ID that we got here in the event. So whoever requested redraw, whichever event like window requested that, we're gonna basically use its window ID to retrieve its own render, right? So self.renders get mutable window ID, and then we're gonna say render.render, and so yeah, that's let's keep it as red here, for example. And yeah, that's basically it. Now you could basically create how much ever like you want of windows and renders. And that's basically it. Now we have a lot of things to fix around here. But let's see. So the first thing that I want to actually do is the fact that, let's say we want to create multiple GPUs, right? Or let's say that the GPU, we got like a device lost error. Like for example, for whichever reason, let's say the GPU crashed, or the driver crashed, or the driver got updated or something, then basically some vulkan function would get vulkan like device lost, you know, error. And most engines, and especially tutorials, doesn't handle this right. So how we could actually do it? Well, the first step is actually making a GPU separate from the renderer. So that's at least that we have done it already. The second thing is that this entry and instance, we should share them. We shouldn't make them twice. So this is like your entry to the driver, to the vulkan driver. You don't have to make it twice, right? So you only want these like one time per application. And also this would allow us to, let's say for example, if we have two GPUs, then one window could use that GPU and the other would use the second GPU, and so on, or whatever you want, basically whoever is using the engine. So what I'm gonna do is I'm gonna make another struct called, you could call it whatever you want. You could call it driver, context, whatever. I'm gonna call it driver. Why not? Because like, you know, kind of like the vulkan driver, right? Because here literally when we create an ash entry, we're basically just loading the vulkan dynamic library functions. Like we're loading the vulkan functions from the library, the DLL, right? And then the instance, you're supposed to create this vulkan object for your one time for your application, right? So it's like your identity in some sense, your identity to the to your application for the driver, right? Either way, that's basically it, and now we don't need it here anymore. And so the GPU would only have like the physical device, the device queue, etc., etc. And that's pretty cool. The other thing is that this surface extension, it's an instance extension, so this should probably go here with the instance too. And that's pretty much it. Now let's actually create this driver. So we're gonna implement driver, and here we're gonna basically, yeah, let's see. These required extensions, let's see, enumerate required extensions, display handle is raw, instance, create instance, extension names. I mean, honestly, you know, just copy this part, really. Yeah, just copy this part so I don't have to like proofread this. Or, I mean, it seems to be the same, so fine then. Fine. Now here, instead of taking the display handle, what we're gonna take actually is a driver arc. Right, and to be honest with you, I'm gonna make this into a factory function instead of a new function to make it clear to the user of this API that this GPU should live as long as the driver. So like there's a parent-child relationship here, right? So instead of having like a freestanding new function, I'm just gonna take all this. The other thing is that I don't have to make the driver fields visible to this guy, right? So let's just take this, remove the new function for now, and let's see what we could do here. So in the driver here, we're gonna say fn create instance. Create instance, and we're gonna honestly, let's just remove this GitHub Copilot right now. It's very noisy. It kind of distracts me. All right. So let's see what we're gonna do here. Also, there's some other AI completion that also sucks so bad, even worse. Wait, let me see, where is it? Code completion, I guess, or inline. Yeah, there we go. Let's remove this. Thank you. All right, so here instead of create GPU, we're gonna say create GPU. And in fact, you're supposed to actually give it the physical device you want to basically use. So here's our code basically, and this should be GPU, I believe. Now we're gonna see about that. Now for the physical device, honestly, we're gonna take it from the user of this API, from the caller. Since we're gonna make this into a library soon enough. Alright, so how are we gonna do this? Well, we're gonna take a physical device. VK physical device. And we're gonna basically use that. Alright, the other thing here is that we need self, of course. So, wait. I guess self like this, right? I think so. Self. So self dot instance dot create device. Right. Here self dot instance. And what else? Let's see. Allocate command buffers, and of course this should return actually an anyhow result of GPU. Okay, and here we got entry, and we don't need that anymore. We're just gonna take an arc of the device, so we can make sure that of the driver, so we can make sure to outlive it, right? And for that we could actually say arc self to make sure it is actually an arc, right? And then what we could do here, basically, we could say that we could store basically the driver here, right? So driver arc, of course, arc driver. And here we're gonna say driver is basically driver, well, self.clone, right? So we inject the driver there, and yeah, that's basically it. We got queue, command pool. All right, perfect. Love that. Other than that, what else we got here? So create GPU, driver, perfect. And wait, where's the extensions? We did it here, so it goes here. Okay, I remember there is some other extension. No. Alright, cool. Now what's next? Let's see. So here we got driver. So basically here we're gonna say self.driver.entry, self.instance, self.driver.instance, and here same thing again, self.driver.surface extension. What else? We're gonna do a lot of refactoring today, and in fact you're gonna learn a lot of Rust on like how you can create your own library and so on. Other than that, we're good. GPU arc. Now I'm gonna do the same thing with the renderer, or actually really wait, do I want that? Maybe not though, I am not sure. Should we do that? Not really, I think. Okay, so let's actually see if this works currently. So here we got arc new, GPU new. So instead of this stuff, we're gonna say actually, well, first of all, we gotta actually need a driver, right? So let driver is equal to driver. So arc new first of all, driver new, and here we're gonna give it the event loop. Alright, and then what we could do here, we could say driver dot, well of course let's unwrap this, and then here we could say, wait, what do you mean by cannot move? Cannot move what? That's strange. That is strange. What is trying to move here? I'm confused. Okay, I think we had to basically unwrap that because it was a result, I believe. Yeah, alright, cool. Now we have to create a GPU. So driver.create GPU, and here we need a physical device, to choose a physical device. Now here we're gonna actually just like, well, the driver would basically contain a function that would give us all the possible devices. Fn, like enumerate physical devices, right? And basically we're gonna say self, and we're gonna basically say self.instance.enumerate physical devices, and we're gonna return those, though this should be in safe. And can it error? Yes, it can. So we're gonna return anyhow result. Anyhow result of vector of vk physical device. Whoops. Physical device. There we go. And let's remove this semicolon so it returns it. And let's unwrap the result. And probably we need OK here. Okay, there we go. Enumerate physical devices. Now what we could do, we could go wild with that, but for now we're only gonna choose the first physical device because I only have one GPU anyways here. Well, so let physical device is equal to driver enumerate physical devices dot into iter, because I don't care about the whole list. I'm just going to take the first one in there, and if there's no GPUs, I'm just going to crash for now. And then here I could tell it which physical device I'm interested in, which is this one. And now what? Expected vacay definitions. Wait. Vacay physical device. And so what? That seems fine. Oh, Vivek physical device. Ah, gotcha. They should be enwrapped first. Alright. And that's basically it for the GPU. Now let's actually just enwrap this too. And now we got self.gpu equals to some GPU.clone. Well, of course it should be in an arc here, and let's go. And then we got a window and a renderer ID. Alright, that seems good. That seems good. Is there any other warnings? Fields. Other than that, let's see if this still works. And there we go, it actually works. Now if I want to, let's say, add another window this time, then here's how it works. You just basically say, you just copy this part, kind of. And yeah, that's basically it. And you just like insert the new ID here and you're good. There we go. Perfect. Now let's actually go further right now. So let's actually make this into an actual library, because right now it's just a little binary right here. So how are we going to do this? Well, this is going to be quite interesting. Let's basically rename this into lib. So it's going to become lib.rs instead of main. So it's going to be a library which other people could use. Now, what we're going to have also, well, actually, you know what? Not really. Let's undo that. And let's actually make, first of all, a folder called examples. So this is going to be our examples of our library. And we're going to put that main function there. Yeah, that may suck. Let's just do it manually, honestly, fine. Don't attach to module. We're going to call this clear color example. And we're going to add file to get fine. And we're going to basically paste all that code there for now. And here we can, as I said, we can basically rename this to lib.rs. Lib.rs. And now let's see. So this part is for the application part, not the library part. But this part is for the actual engine library part. Right. Cool. So what we're gonna do here, and for the clear color, kind of a similar thing here, but in reverse. So we're gonna remove all the engine parts. Oh boy. Struct driver. So I'm gonna remove all that. And there we go. Alright, so now let's actually split this into modules. So we're gonna make a module called, let's see, core. Let's go with core. We're just gonna have some basic stuff, which basically would be, in this case, Rust module. We're gonna call this driver. So this is gonna be our driver here. So I'm just gonna basically take this code right here, from here, put it here. And we're gonna have other modules right now. Rust module, GPU. And we're gonna basically cut this, well, not here. Let's go to here, I guess. Yeah, so let's cut this GPU parts. and let's put it into its own module. Right, now let's go here and let's put the struct render stuff into its own module too, and we should be done. Rust module, right? Yep. Okay, and we're gonna call this render add. There we go. Okay. So that's great. Now we have to fix some few things on terms of visibility. So this struct renderer should be, well, let me see. First of all, this arc GPU, or actually, yeah. Let's start from driver, actually. Let's start from driver. Fine. So this should be public, right? So, but driver for now, we're gonna, well, yeah, honestly, So the thing is, what I'm thinking about right now is that this part, you know, of having renders and windows being handled like this, it's really the job of the engine, really. So what I'm gonna do, I'm gonna make another folder here instead of core, outside of core, because this would depend on winit, and we don't want the core of the engine to depend on something as big as winit. So that's what I'm gonna do here. So new directory, and we're gonna go with what is it called? Core, and let's call this graphics. Fine. And it would basically have a Rust module, right? Yes. I'm gonna call this graphics, and let's go. Now this would contain a struct called, or honestly, I'm just gonna go here, well, to the clear color function. I'm just gonna take this whole thing, this whole struct. Well, in fact, yeah. So, and let's go here, and we're gonna have this here. Cool. And what we're gonna do now, let's see. So instead of app, this is gonna be called graphics, right? So this is our kind of like our graphics subsystem of the engine, right? And what else? And this would be public. It's not gonna be derived default. This is gonna be, well, public struct graphics. And here the GPU wouldn't be an option anymore because we don't have that thing. Great. So how we could add this to, now clear color would basically, instead of storing this, it would store graphics subsystem. It's gonna be an option, of course. Option graphics. Now we need to basically make that public. Oh, well, we already did, yeah. So how do we add this? Oh, this should be called, what is it called? Mod, I believe? Yeah, mod RS, okay. So let's make this called mod. Or instead, we could just make another file called mod here. Rust file mod. So this is like C++ namespaces, but like it's in the folders and files. So that's great. Now let's see, attached file to librs, sure. And now we're good. We don't need this stuff here. Now our mod graphics, let's see, attached to mod rs. And there you go, cool. Now this should be public, so we could use it in our engine, in our example app. So pub mod graphics, pub mod, and pub struct graphics. Cool. Now this should import window ID, and it should, well, what the heck? And it should import render and window. They're not public yet, so let's go ahead and make sure to do that. So here, mod driver, mod GPU, mod render, all of these core stuff would basically be public, but only in this crate. So only to the other engine stuff, like for example, graphics. And so it wouldn't be available to the user of the engine. Right. And that's, I believe, it. Core. librs. Here, pub core. Well, what the heck? Pub crate. pub crate. Let's go. This one though would be public to the public, right? To the other applications that are using our engine, right? But core would only be available in graphics. All right, now let's fix up the errors. So let's import window here. Of course, we need window. And this graphics part would be optional, as you're gonna see in a second. Now the GPU and the render, why? Oh yeah, I need to make them public. Of course, public crate. So struct pub crate. And the other renderer, we're gonna go with pub crate. The driver, pub crate. And the mod, well, yeah, that's basically it. Let's remove that. By the way, remove this. And we're good. Though this should be VK extend 2D like this. Is there any problem? So, driver, is there any problems here? Cannot find type GPU in this scope. Sure, let's import it. And I see. So we need some constructor essentially. Hello Epsilon Phoenix, welcome to the live stream. So how are we gonna do this? Okay, GPU. We should probably make a constructor too simply, I think. Or just make it public to the crate. Or just pub super. I mean, for now we could just do pub super, so it's only available in core. But you know what? The cleanest way would be to just create a constructor here, really. FNU. And it would basically return a GPU, right? So we're gonna return, well, self. Self is basically GPU in this case. And we're gonna add the missing fields here, and let's see. So the first field would be would be the driver, so arc. But to be honest with you, should we go this way? I don't like that, honestly. I don't like that. It's like every time I'm gonna add something to the GPU, I have to do it in the freaking constructor and so on. So I either need to scrap that idea of using factory functions, one, or two, simply make these public, which gonna suck. Honestly, yeah, let's just scrap that idea, really. And let's come here to the driver, and let's basically pick up this function from here. Whoops, it's incomplete. Let's take this and remove this. I mean, we could keep it, but honestly, yeah, there's no need. So like it would depend on the GPU for no reason. Let's keep them independent, really. Yeah, let's keep them independent. There's no need to couple things that are, yeah, sure. So that's good. Now, what are we gonna do here? So new self, we're gonna do this. Right, so now let's see what's up. And we need here the driver. So driver is arc driver. Create core driver. Okay, cool. And here, well, self, what the heck? Yeah, self is basically driver in this case. Hello XYZ, thank you so much. Thank you. Now, driver.instance and type mismatch, expected GPU but found result. Yeah, let's actually go with anyhow. We should actually change this to honestly this error instead of anyhow, but let's go step by step, right? Let's go step by step. Now this guy should So creating like Lloyd in the swap chain extension and creating a device. So let's actually add that here. So fn Lloyd swap chain extension self anyhow result. And here what we're gonna do, we're gonna say vk-char, well, what the heck, ash, I believe ash, yeah, ash kchar swap chain device or instance, yeah. And oh yeah, actually we said that we want, no, that's the swap chain. Well, that means the device. I'm not sure why they even put an instance there. Anyways, other than that, we also gonna need creating a device. So self again, anyhow result for now. And let's grab that stuff. So here, for example, let's create device, would go there. And we're gonna return this. So like, gonna return okay. That though this is in safe. And this should be self. Now cannot find, yeah, so you gotta basically tell it which physical device you're talking about. Yo, what the heck? Anonymous, oh yeah. Physical device. Let's just say to do for now. And what else? But found ash device. What do you mean? Expected ash extensions generated kchar swap chain device. Oh, what the heck am I doing? Create device. It should be ash device. Right. Okay, that's good. We're gonna keep these hard-coded for now, honestly, I guess. Enable extension names, queue create infos, queue priorities. Yeah, fine, let's keep them that way. And now the swap chain extension. Let's see what we got here. So swap chain extension, we're just gonna return this. Let's see. And so self dot, well, this is gonna be like the device, vacate device, right? Though these should be public in the crate, and this one also public in the crate. Now what's going on here? Well, that should be ash device reference. Now this should be also, well, do we actually need any, hold on, what this returns? It returns self. Okay, so we don't need results really in this case. And I believe that's basically it. Right, cool, love that. Now let's see what we got. So GPU, now instead of doing this, we're gonna say driver dot create device, and we're gonna give it the physical device. Wait, yeah, physical device, and the physical device, we're gonna get it from the user, from the caller. He's the one who's gonna choose which physical device he likes to use. Well, there we go. Now swap chain extension, we're gonna say driver dot Lloyd swap chain extension, and here we're gonna need the device that we've just created. And let's do that, and this should need a reference. And there we go. Okay, lovely. separation of concerns. So the driver do driver stuff, the GPU do GPU stuff. That's perfect. Love that. So I'm just gonna make sure the order of destruction, I mean, it's fine, it doesn't matter since these vacay structs doesn't actually implement drop, but it's a good practice just in case if I sneak in something. Like for example, arc here, it does. So I just gotta make sure its order is good. So I kind of basically need to like order this the other way around. So like the driver comes first, then the physical device should be this, then the physical device, then the device, then the queue, then the command pool, then the command buffers. Though the swap chain extension right after the device, I believe, yeah. And we're good. Okay, so just making sure the order is right. Why? So the command buffers will get destroyed first, then the command pool, then the queue, then the swap chain extension, then the device, then the physical device, then the driver, right? So that's great. Next up, what we have here. So this one creates surface. All right, so this is the job of the driver apparently, since it needs entry in the instance. All right, so let's take this create surface function. Whoops. And let's give it to the, I mean, honestly, we're gonna keep the function here. We're just gonna copy it, go to driver, create surface. Here we're gonna say self. Well, let's remove this driver thing and we're good. That's how you create a surface. And then here the GPU, we're just gonna tell the driver to create the surface. What the heck? Well, I need to make it public. Pub create. Now create surface, and we're gonna give it the display handle. And there we go. In wrap. Or actually not in wrap. Just gonna return this. Yeah. And there we go. Though, do we actually need has display handle here? I don't think so. Yeah, I think, well, actually it is, apparently, yep. It is. Well, I mean, hold on. Oh yeah, we actually do need that, right. Cool. Cool. So, let's keep it. And this is actually just like the window, really. Just call it window, actually. And for the driver, I'm gonna call this display. Other than that, we're good, I think, in terms of the driver. Now, let's see if there's any other errors in terms of the GPU. Here we got surface capabilities. It needs the surface extension, which is in the driver. And finally here, destroying the instance, which is not the job of this guy, it is the job of the driver. Now the surface extension, we need to get the surface capabilities. Okay, so let's actually copy this part. And let's go to the driver. Now, before I forget, let's make sure to also implement drop on the driver. Drop for driver. And let's implement the members drop. And let's destroy everything here that we don't need so anymore. So like instance, surface extension, etc. I think I don't. Yeah, let's go. Wait, what the heck? Self dot. Instance, yeah. Destroy instance. Self dot instance. Other than that, that's the only thing we need here, really. I believe. Right, so. Oh yeah, to actually remove the instance. Cannot move expected. I see. Can we just clone it? I believe. No? Wait, what? I think we need none after that. No? Wait, what? I'm confused right now. Destroy instance. Is Rust better than C++ these days? In my opinion, yes, but everyone have his own opinion. Hello, just 13 try. Welcome to the live stream. This method takes 1 argument, but 2 arguments were supplied. Ah, okay, gotcha. So I should just say none, though. Alright, perfect. Perfect. Now, here we're gonna need to create a surface. Pub create fn. Well, not really. Get surface capabilities, yeah. Get surface capabilities. And you're gonna basically return these. And so this is basically anyhow result vacate surface capabilities khr. Alright, and here we're gonna need self, and we're gonna need the physical device. Also the surface apparently, yeah. Surface khr. Right, now physical device, and here we're gonna say okay, and let's remove that. And this. Any tips for learning how to code? Depends on your goals. Why are you learning? Why you want to learn to code, and for what, etc. And welcome to the live stream, Akil. To become a software engineer, I mean, even becoming a software engineer, there's a lot of professions. You should basically, first of all, try various fields. They're vastly different. Like computer science is like a very, very fast field. Try low-level programming, try web development, try, what else? Compiler stuff. There's a whole bunch of stuff you could try, a bunch of subfields, then see what seems to be fun for you and pursue it, basically. So yeah, alright, so that should give us the surface capabilities. But like the most important when you're just starting out in a field is to explore first of all what's the possibilities. You know, because like if you didn't try multiple things, you don't really know what's the best for you. Every person is better in some place, basically. But yeah. I'm gonna get some water real quick. Okay, back. Alright, let's see what we got here. So here we got surface capabilities. Let's do that. So self dot get surface capabilities. How do we do that? Oh yeah, that should be, oh my god. Well, it's already, what the heck? Well, the driver gets surface capabilities. Yep. Now, of course, here we're gonna give it like the oh, the current surface. Okay. Well, the physical device first, which is self.physicalDevice, then the surface we're talking about here. Alright, so basically we have these independent kind of abstractions. Everyone is doing his own job, right? So, and each one kind of contributes something. Right. Now we have the driver good, the GPU good, perfect. Anything else here? Not for now, at least. Next up, the renderer. Let's fix up the renderer. So the GPU, we're gonna import that. And let's just make these public. So C-line would help us here to make them all public. There you go. I don't know if there is a faster way to do this. Let's make these all public. So I just decided to like do the refactoring today before we go to anything more serious than this. So we don't have to like refactor a whole bunch of crap later on. So like the more you wait, the more the tech depth goes on. Right? So yeah. And yeah, pretty much. Now the renderer is perfect, I think. I mean, there is some stuff that we have to check out later on, to change later on, but right now, at least to fix the errors. Same thing with the graphics right now. We're gonna import that. So this one is new actually, we didn't have it before. It was in the application actually, but right now we're moving it to the engine. So the user doesn't need to care about juggling windows in their own renderers. Like, I mean, it's gonna be optional, unless like if you want to pull in WinIt with the engine, then it would actually include it as kind of like a helper in some sense. But I'm not sure, we'll see about that later on. Either way. So we got the graphics, great. Now this, let's implement some functions on this graphics. So this is like our graphics subsystem. So this should be public, of course, pubfn new. And let's see, first of all, we can of course make a GPU here. So let GPU is equal to GPU new, right? I think so, though maybe it's not public or what. Yeah, let's make this new public. And we also need a driver. Yeah, I forgot. So, and both of these should be in Arc, I believe. Right, so driver new. Import. Let's make this new public. Same thing with this arc, new. And now let's see what we're gonna need here. So let's fill the missing arguments. Oh yeah, we're gonna need here the display. So the display can be basically this, something that implement has display handle. That's basically what a display is in this case. It comes from the raw window crate. Now GPU new, it needs a driver and it needs a physical device. So we gotta choose a physical device here. For now, we're just gonna choose a physical device for the user here. So let's see, driver.enumerate. Wait, what? Oh yeah, this should be. So let's propagate back the error if there's any errors. And basically self here, cool. Now we could say enumerate. What the? Yeah, I believe it's not. It's not public probably. Enumerate physical devices. We can make it public. Yep, there we go. And it would give us a result. So let's unwrap that, and then we're just gonna take the first physical device, the first GPU we find in the user system. So into editor next the unwrap, or we could just do this and say anyhow context. So what is it called? Context with context or context? Honestly, for now, just unwrap, please. I'm just gonna crash for now. All right, cool. Next up here we got this. We need to unwrap the result, and yeah, right, we're gonna say okay self, and here we need to also store the driver here. I mean, we don't actually have to in this case. You know why? Because like, since this is an arc, and so as long as the GPU the GPU is living, it would make sure that driver is living anyways. But let's just keep it there, fine. Let's add the missing fields. Well, we're gonna need the windows, the renders, and the driver. Wait, what? We need this to be the driver, right? So now let's actually make a Windows hash map. And the renders hash map, it's gonna be empty at first. Then the user can basically create new ones. What the heck? Really? That's strange. Why not renders and windows? There we go. Value used after being moved, because here we're actually moving it. Let's clone it. Here it's like, you know, not cloning the house, it's just cloning the key to the house, right? But yeah, either way, so that's basically it for that part. Now let's basically implement a function that would essentially create a new device, a new window with its own render, right, at the same time, instead of the user application juggling those. So we're gonna have a public fn add window, and here the user would give let's see, window attributes, or sure, window attributes, and I believe that's basically it. Now it's gonna give the user back a window ID for the newly added window. Alright, cool. So first of all, we're gonna create a window, though we're gonna need the event loop though. Alright, so for that we're gonna take an event loop, fine. So active event loop. So event loop dot create window, and we're gonna give it the window attributes that we got from the user. This is kind of like basically making the interface way more ergonomic. Right, and here of course there should be a result though. So anyhow, results. Right, later on we're gonna change anyhow with this error, because this is a library. We should have some more robust error handling, but for now we're good. And next up we're gonna need, let's see, so we need to create a render. So let's create a render for this window. And how are we gonna do that? Render new. Let's make new public here. And let's see what we got. So arc new. So we need basically some data and window handle and extend, Wait a second. You're gonna need the GPU first of all, so self.gpu. Well, we need self, of course. In fact, we're probably gonna need mutable because we're gonna add them to the hash maps. Right. Next up, why I can't give it this? That's weird. Well, we gotta give it a clone. Next up, I mean, come on, why this is not helping? So the window handle. So here we're gonna give it a reference to the window, and next up, the extent of the window, right? So window inner size, no into, because that's an array, not extent. And that's basically it. And let's unwrap that. Next up, we're gonna add these window and render to the hash maps that we have here. So how are we gonna do that? So first of all, let's grab the ID. So window.id, right? And then what we're gonna do here is self.windows dot insert ID, comma window. And next up, we're gonna say self.renders dot insert id comma render. There we go. Now what we're gonna do here, we're gonna return a window ID finally. Okay, ID. So basically we're just giving the user the ID of the window. Cool. And that's basically how you add a window. So here we basically take care of making a new render and a window for the user and registering them essentially into our graphics subsystem using our GPU and so on. Vero, do you get tired of speaking out loud like this, or is it part of the thinking process? Not really. Maybe I got used to it. I'm not sure. It's been a long time since I've been doing this. I do get a bit short breath. Other than that, yeah, it's good. And also part of my thinking process. I really like to think out loud. Really. Yeah, I see. That's relatable. Though when I program alone, of course, I don't actually think aloud like this. But yeah. Though when I'm thinking about like generally not actually programming, yeah, I do think aloud pretty much. Other than that, so we got an add window. So obviously we're also gonna have a remove window. So the user would tell us which window they're interested into removing, and then we're gonna do it. So here we need a window ID. So ID, window ID. Hello Mucho, welcome back. How's it going? Thank you for starring my GitHub repo, by the way. I just noticed. Okay, so remove windows. So self dot windows, we're gonna remove that specific ID. And self dot renders, we're also gonna remove that. So remove that specific ID. Perfect. And that's how you remove a window. We just remove the window and its renderer. And that's basically it. So since we're not using this, honestly, since we're not using it, let's just remove it. The arc would make sure that it stays alive, so we don't really need to store it too. So fine. And also we don't need to clone the arc here since we don't need to store it ourselves. The GPU would take care and make sure that the driver stays alive as long as it's alive. Since we're using an arc, which is great. Okay, so add window, remove window. Next up, we're also gonna need some resume function. So this is what would happen when the application get resumed. For example, let's say in Android, when you go back to the application, it was in the background and now we're back into the game, right? So how you do it? Well, good question. Mutable self, let's see. So basically, well, in fact, to actually understand what we're gonna do, first of all, let's show you what we're gonna do when suspend happens. So like when the application goes into the background. So like when you quit the application, but it's still running in the background, what happens? We need to make sure to remove all the renderers, not the windows, just the renderers, because they're not invalid. The surface is not invalid, not valid anymore. So how are we gonna do that? Well, since we're using RAI as they call it in C++. Of course, in Rust we call it drop. What we're gonna do here, we're just gonna say self.renders.clear. We're gonna remove all the renders, and it's gonna make sure to destroy all that objects, GPU objects for us. Though we gotta make sure that the renderer is destroying its objects, which we're gonna do in a second. Other than that, here we got the resume. So the resume would go ahead and recreate all the renders, essentially. So what we're gonna do, how are we gonna do this? So like for every window in self.windows, now of course this would also give us the ID of the window. What we're gonna do is self.renders.insert ID, comma, and here we're gonna create a new render. Self.gpu, comma, well, of course we gotta give it a clone here of an arc, and the window reference and window.innerSize, not into. And what's up? Oh yeah, this is a result, so let's unwrap it. Right, yeah. And I'm just gonna make sure to actually return a result here. And let's see. So yeah, that's pretty much it. We're not gonna return anything, just a result. And if everything goes well, we're gonna return okay. And yeah, that's basically it. Though we cannot move out of this. So we gotta make sure we just only iterate through it, not move it. So we gotta do this. And since we're doing that, we don't need this. And here we're just gonna say this. And yeah, that's basically it. Otherwise, you could also say self.windows like map. Could say iter map and just say, so this would give you basically the window and the window ID. So like ID comma window. And then you could basically do this, I guess. Wait. How are we gonna insert them though? Good question. How do you do it? I'm pretty sure Rust would have something for that. Let's see. Self.renders. Is there like some way to insert like maybe extend, I would guess? Probably extend. Yeah, probably extend. Though for that you probably want to return ID like this, maybe. But you know what? To be honest with you, it's more clearer this way. Fine. For now at least. So yeah, that's pretty much it. So resume, suspend. And that's pretty sick. What else? We're also gonna need resize, which we haven't implemented just yet. Alright, cool. Let's make sure, by the way, that well, let's see now what we got here. So option graphics, import, and so the application doesn't need to do this, you know, aerobics anymore, right? So that's done by the engine right now. Is your engine now blazingly fast? Welcome, Thanos Fisherman. Hopefully. We're gonna see about that. But I'm doing my best, I guess. Alright, so let's see how we're gonna do this. Self.graphics is equal to, well, it depends. So resumed would happen twice, like in two states. At the start, which means we're not gonna have any graphics subsystem started yet, and when we resume back from just a background state, which means we do have a graphics, but it's in a suspend state. So what we're gonna do, we're gonna say if let some graphics equal to self.graphics. So we're gonna check if we have the graphics subsystem started already. Graphics as ref. I think though as mutable though. Yeah, as mutable ref. Right, so if it is not started yet, then we're gonna actually create it. So graphics is equal to graphics new, and here we're gonna give it the event loop. Perfect. And well, let's unwrap if there is something wrong. Next up, what we're gonna do is right now we could actually make some windows, and it's gonna give us back the ID. So graphics.add window, too simply, no juggling of renders and windows in the application code. That happens just in the engine code, right? So that's great. Okay, so we got the event loop, and here window attributes, which we could just give it the default for now if we don't care about changing the title or something. Other than that, we're good. Make graphics mutable, and here in wrap, crash if there's any error for now. And yeah, that's basically how it goes. Currently, we're not going to be using the window ID for anything, but you'll see what's that going to be useful for in a second. Now here, graphics. Now, if we have graphics and we're just resuming, so basically the app just got back into the foreground from the background, what we're gonna do, we're gonna basically make sure to resume. So basically the engine would go ahead and recreate the renders, which is great. A lot of engines, don't even talk about tutorials, but a lot of engines, even Bevy, like, had this problem before, but they fixed it in Android, where like it doesn't work because they're not handling this case where the app gets suspended, right? So here we have another function. So where is it called? Let's see, generate. Ahmed Ilamin, welcome to live stream. I have an interview coming up where it will be me jumping into the code base, type script, and try to optimize the code. Do you have any advice on optimizing debugging code? Well, TypeScript, what technology? Web? And if web, what kind of technology exactly? Is it like Svelte or what exactly? Implement methods. So here we got suspended. Now if suspended happens, what we're gonna do is we're gonna say self.graphics, and we're gonna say as mute.inwrap.suspend. So here, well, the engine would basically make sure that all the renders would get destroyed before the surfaces would be invalid. Yeah, web Svelte that runs on a bridge to run native on iOS. It's weird. I don't know. I don't really develop in web, unfortunately. I'm doing like low-level graphics development, so I'm quite far from... I did web a bit, but I can't really give... I don't have anything in top of my mind, like, on how to... I mean, it depends on the code, really. Yeah, I mean, if I see the code, maybe I could figure it out, but other than that, I don't have anything in my mind right now. So... add field renders to type app. So here when redraw requested, well, yeah, I forgot this one. We need basically something called redraw, right? So let's make a redraw function here. pubfn redraw window. And you're basically gonna give me the window ID. And I'm gonna make sure that happens. So we're gonna go self.renders.get id dot inwrap. Huh, wait. Yeah, and is there a render function? I believe there is a... I hate and love Rust so much. Hello Anonymous, welcome to live stream. Why do you hate and love Rust? Method render is private. Let's actually make it public. And there we go. This method takes one argument, which is the clear color. Oh yeah, the clear color. The clear color. So we're gonna take it from the user. It's funny you mentioned graphics. They told me the hardest thing they're running into is feature like dynamic drag and drop and seat management. Not sure if that's relevant to graphics. Kind of, but more like UI development, really. Not exactly low-level graphics. But it's close. It's close to some degree. Alright, so U32. U32. 4, I think, right? Oh, oops. F32, okay. And let's, well, not in wrap. We could just, I guess, do it this way. Anyhow. So here I'm just making sure that our architecture of the engine is solid before we move on into some other things. So we don't have to refactor a lot of crap later on, right? So better early. So yeah, all right, so how are we gonna do this? Well, okay, if everything goes well. And what's going on here? So do you think it is a waste of time to watch other people coding like this stream if I struggle with on-the-fly code writing, or is it better to just do it myself even if it's super shitty? I mean, if it's about Rust, Vulkan, and graphics development, then you would probably benefit way more, you know, like watching organic streams like mine, where I actually just, you know, live like debug stuff and things doesn't work and I try to figure it out. Like something I don't know, I try to figure it out and stuff. You're gonna learn way more than like a prepared tutorial that just goes through and doesn't show you the errors and so on. Other than that, if it's about web, then you're probably wasting your time watching this tutorial, really. Web is another field, pretty much, unfortunately. I kind of don't like web. I don't find it very exciting, interesting. Like engine development and graphics, I find it very interesting. I'm thinking about learning Rust, but right now I'm learning C++. What do you guys think? T-Man. I really don't recommend learning C++, especially if it's your first low-level language. I recommend at least learning C first, and then learn Rust. And then if you want to go to C++ after that, then go. Because the thing is about C++, you're going to need to figure out ownership and lifetimes and so on, and C++ doesn't really make it clear how that stuff works. You're only going to learn it with the errors of Rust. And for memory, C++ abstracts that, kind of like Rust. So you're not going to learn much about how to handle memory yourself manually. That's the job of the C language. So I recommend to learn C first. I mean, you could go with C++, fine, but you're going to have like, it's going to be hell, right? You're just going to waste a lot of time, right? So the path I recommend for learning low level system stuff is learn C first. Learn how to allocate memory manually, what's going on exactly. It's very explicit. Or maybe Zig, though the problem with Zig, there's not a lot of tutorials out there. Though either way, either Zig or C, because these are very explicit about where you allocate memory and what's going on. So like there's no magic essentially, right? Then go to Rust because you're going to learn ownership and lifetime, since the compiler yells at you all the way along. So like if you're doing something wrong, the Rust compiler would tell you that here, this lifetime or this or that, there's something wrong. And just, you know, read the errors and try to fix them, first of all. Otherwise, if you can't, then go to ChatGPT. Ask it why I'm getting this error in this particular code. It's way even easier. So yeah. Learn C, then learn Rust, and if you want to learn C++, then fine, go ahead. Alright, so is there a name for these type of streams? I don't think there's like an official name, but yeah, live coding. 60 Tim, use bro using Rust Rover instead of NeoVim? Yeah, I'm using Rust Rover. Okay, but now finding myself not being able to learn C. C is very actually easy. I don't know what to say, honestly. Mucho. Every dev should have some experience with C to understand what is happening. It's actually quite nice that there are not a lot of features and keywords. Use Valgrind, it will be good. Yeah, learn C. I really recommend learning C as the first language, at least for low-level programming. If you don't care about low-level programming, if you only care about like making scripts and so on, then go with Python. Or even TypeScript if you're in the web space. But yeah. So now here we're sure, well, I mean not sure though. Well, I mean here we should really make use of this error to make it clear to the user what exactly happened. But for now, let's just inwrap, really. Let's just crash. I cannot borrow data in the reference is mutable. What do you mean? In a reference cannot borrow. Oh, I think get mute. Yeah. Right? Make self mutable. Okay, cool. And that's basically it. I already know a bit of C. I try to make a physics engine, you know, jump in, and that's about it. If I did learn Rust, what would be your best learning resource? My best learning resource, I would, again, I don't really have like a particular resource that would teach you like everything. what can I say? But I would recommend the Rust book first of all, as always, as anybody would recommend. That's the first thing. The other channel that was really helpful for me, especially when I was in my intermediate phase of Rust, is John. Guest, I think. I'm not sure what his name. This guy makes some live streams, kind of like me. Yeah, there we go. This guy. He makes live streams like me, but covering something, right? And he's very good at explaining that stuff. I really recommend him. Otherwise, after that, I would recommend checking out like live streams like mine and like, let's say, solding and so on, where they like actually make stuff live instead of just teaching you one feature of the language at a time in a perfect manner, right? So you could see the process of their thinking, how they debug, what would they do when something goes wrong, how they think about the problem, etc. And also, since it's live, you could literally like ask any question about anything at the same time and you get an answer directly. And of course, there's ChatGPT. If you have something you don't understand, looks fuzzy, then ask ChatGPT. It's pretty good. Just make sure you use ChatGPT as a like learning partner instead of like, you know, telling it to code your stuff. You're not gonna learn anything like that. But like, you know, kind of, it's like ChatGPT is like your own kind of like low wage worker, right? Like teacher basically that is available 24/7. So yeah, it's pretty cool. What else? When did you first start programming? Sorry for the constant question. It's fine. If you guys have any questions, please let me know. I started programming, I think, 8 years ago. I started with Roblox, though. I started with the Roblox development, so like game development. I was trying to make Roblox games, because like the thing is, I started by basically, I was playing a Roblox game, and then I was thinking like, how the heck these games are being made? Like, bruh, what the heck? And yeah, I figured out that there's some other application called Roblox Studio also on my system that got installed with Roblox. And I figured out that the game I was playing is made by someone just like me. No one special, like not really a company or something. It was just some other person with a program that is installed currently in my system, and I was like blown away. I was a kid at the time. I was like, I guess 13 years old maybe or something like that. And so yeah, there we go. And I started learning Lua, and I became kind of like an expert at Lua, really. So like 5 years of Roblox. Then I decided Roblox wasn't enough anymore. I wanted more. I'm hungry for more because like, yeah, I see how you make those games, but I wasn't sure exactly how that stuff actually works really under the hood. Because like, most of the crap is done for me by Roblox engine, right? So I wasn't really sure. Yeah, here we go. I'm making this sprite and I'm moving it. I'm making this part and it moves. Yeah, cool, fine. But how does physics works? How the rendering works? How? That's where you go into low-level development, pretty much. You know what? When I started using Clip is when I started really understanding Rust. Oh yeah, Rust really helped me because like I kind of started with C++ because it was the only option at the time, right? And C, of course. And I didn't really understand what is lifetimes, what is ownership, and a lot of these concepts I had no clue, and I was constantly getting stuff wrong, you know. And like, for example, I would make like, let's say, shader abstraction and the move constructors in C++. In fact, even right now, C++ still tipped me over because things aren't really that explicit in C++ and a lot of crappy syntax. Like, for example, if you make the destructor, like you have to also implement some 5 more, like 4 more, actually 3 more functions, I believe. Like there's the copy constructor, copy assignment, and all that crap. It really sucked. But when I came to Rust, it became clear. Like stuff is very clear. Like here, I'm sure that the active event loop is not being owned. It's just getting a reference. In C++, though, references aren't very clear and so on. There's just a lot of crap, really. And also the compiler just lets you shoot yourself in the foot, so you don't really know what's wrong until you spend like a week debugging something and hopefully figuring it out in the process. But in Rust though, if you do something wrong, it tells you exactly what you did, and you're forced to deal with it at the time instead of later on in some obscure way. And in fact, even right now, like C++ still trip me, and I get some weird sig faults and so on that I can't figure out. But in Rust, that doesn't happen. Okay, would you program every hour of almost every day? The stuff you're doing seems like it requires a lot of experience. Yep, it definitely definitely. Like low-level programming, it's really not for the faint-hearted. If you're not like, especially Vulkan, like if you're not really like enjoying this like I am, please just stay away. You're not gonna like it, right? So if you're just coming like, let's say, programming for just the money, or just go with web development. If like you want a job, go with web development. Like really low level dev wouldn't really do it for you. Anyways, do you ever feel tempted to use AI? I feel like I use it too much. I use AI daily pretty much, but I don't use it like, write this whole program for me. I use it, why this thing or why that. It's like, kind of like my coding partner, or like some other students with me. Kind of like we figured out things together. It's like a friend, basically. We basically also explore ideas, or let's say, for example, you could give it some code and see how that code would become in another language very quickly instead of rewriting that whole thing, and so on. Kind of like science fiction, right? So you could basically explore some interesting stuff really quickly. Are you using Volcano or Ash? Currently I'm using Ash, pretty much. Is it possible to fall in love with stuff, low level graphics, all the hard and crazy stuff? What do you think drew you the most? The challenge? Definitely I love this stuff. Well, I can't really say for sure that. Of course, at first, like, it's a challenge. Like, why the heck I can't make my own engine too? Yeah, that's the first thing. Second thing is like very much curiosity. This is what started this whole mess. Curiosity. Like I was curious, like how the heck these games work under the hood, and there we go. So yeah. All right, let's continue, I guess. The Janzep, welcome to live stream. What do you think about Rust debugging? Coming from C#, I have been a bit disappointed by the Rust rover not being able to pre-print some types. Pre-print like what? It's actually fine. It's pretty good. Rust debugging is pretty good. You don't have to start hardcore. Maybe it would be a more pleasant experience using the engine first. Yeah, definitely. Like if you're not interested to like understand how these things really work under the hood, you're not curious, you're not passionate, then don't even mess with this. Just use a freaking game engine. don't sweat it, or just go with web development. Pretty much, like, it's just not worth it. Even game development, it's pretty hard. Like even using a game engine, like if you're not that passionate about it, you're gonna quit really soon. Like you just can't survive it. That's pretty much it. All right, so where we were. Okay. No field renders in type mutable app. Oh yeah. So here, instead of this right now, since we have abstracted that away in our engine, we're gonna say self.graphics.render. Redraw window. Yeah. Redraw window, and here we tell it which window, which is basically the window ID, and then we tell it which clear color we want. Currently red. So wait, what's going on here? Cannot move. Yeah, because this should become as mute. And there we go. In wrap. There we go. Sometimes the debugger just shows pointer instead of the data behind it. I think it happens sometimes for hash maps. I mean, let's see what you're talking about. We could do it, for example, but I can't run anything just yet because I'm still, doing stuff here. If I'm really curious about stuff like productivity, like large apps and sites of today and how they operate under the hood, think Google, YouTube, Chrome, operating systems, live streaming, etc. It feels too vague and too broad though. Well, Chrome is like very complex. It's like its own OS. But like if you want to see the code, though you're not gonna really understand much about the code. But like, you know, Chrome is, can I call like open source? I don't think it's open source. Well, like you could read the code, right? So like Chrome repo. Wait. Oh my god. Oh my eyes. My eyes. Okay, I forgot to install this extension. Oh my god. I feel like a bat right now. Okay, there we go. Alright, so what we have here. So you could find like the code of Chrome somewhere. I don't remember where exactly. Chrome repo code. Chromium. Yeah, there we go. I guess. Where can I access the code though? What the heck? Bruh. Okay, so here's the whole code of Chromium. If you're curious, though you're probably not gonna learn much from here, but you could check out like the documentation and things. But like Chrome is like a whole beast. Like there's a whole bunch of crap. Like the web, it's not like just a browser anymore. It's more like an operating system. There's a whole bunch of crap about like security and video encoding and all sorts of cool stuff. Why do you refer to the Rust documentation? I'm curious. Is it the best way to learn a PL? What is PL? And Ahmed Peter, welcome to the live stream. Alright, let's continue, I think. Sandboxing. Yep. Oh, Rashton. I do remember you from somewhere. Welcome to the live stream. Programming language. Is the best way to learn a program. Yeah, I mean, it's like the documentation, especially for Rust, it's pretty good, especially as a reference. If you already know what you're looking for, but you just need to know how to use it, basically. Let me see if this actually works right now. Though it wouldn't, because we changed a lot of stuff. Right now we have a library, and what we actually want to run is the example called clear color here. So we're going to change our stuff here a bit. So instead of running package cargo run package code Chaco engine rs dash bin code Chaco engine rs. Code Chaco engine rs right now is a library, so we need to run this example instead. So we're going to say dash example clear color, and there we go. Now let's try to run this. And does it work? Apparently I don't think so for some reason. So it is running, but nothing is happening. Why? And well, let's find out. Oh yeah, well, hold on. Graphics to add window event loop. Wait. Wait, what? Oh, it's none. Oh yeah, I forgot to actually. Yeah, gotcha. So I forgot to say self.graphics is equal to some graphics. I forgot to store it, so it just get destroyed immediately. That's what's happened. Alright, there we go. We're back into our little clear screen. So now we have a bunch of other issues we have to solve before we go further to So let's say we want to make another window right now. Here's how you do it. You just say, so this is my window 1. Now I could create a second window, window 2, right? And next step, what I do is, let's say, well, let's just run this. And there we go. We got 2 windows being rendered through Vulkan. But now, let's say we want to render one window with a red color and the other with a green color. What we do? Well, here's where window ID would get into work. So here we're going to make our own little hash map for clear colors. Clear colors, hash map, you know, window ID, comma, window. Oh, well, actually not window. I mean, clear color is going to be an array of F32 4. Well, what the heck, 4 like this, yeah. And what you're going to basically do is clear color, well, self.clear colors, window 1 is equal to red. Right, cannot assign. Oh, actually, let's say insert, yeah. Insert window 1. There we go. And same thing with window 2. We're going to insert window 2 and I'm going to say 1 0 for green. And now instead of this constant clear color, we're going to say self.clearColors, and we're going to use our window ID here, because this window ID is the one we're currently rendering essentially. And that's basically, well, let's add that. Now let's try this. Yeah, I forgot a reference here, and we're good. And there we go. So we got a green color and a red color. Boom. Let's say I want to create 10 windows. How are we going to do that? Well, for I in 0 to 10, I'm going to basically insert a window. There we go. Wait, well, yeah, let's just take this, put it here, window, insert window, and here let's say we want to have let C is equal to I divided by 10. Though of course let's make this a float, so as F32 divided by 10, because that's how much windows we have. And now let's say this, we're gonna get C to red, green, and blue to get a grayscale color. And now let's see. And there we go. We got 10 windows being rendered using Vulkan. Each one in its own kind of color. Right? It's really that simple. There we go. Alright, so yeah, that's pretty much it. Now let's just go with one, please. One window for now. Alright, now let's fix up some stuff on the actual stuff, on the, what is it called? On the engine, right? We have a lot of stuff to fix. Alright, let's see. So the graphics is good. There is nothing to fix here. Yeah. The render. Okay, so we have a few things to fix in the render, which is so first of all, the synchronization. So here we're using CMD clear color image, but we actually need some synchronization. We need to basically transition the image state. I mean, currently this works, but it's not the best. Like if you run this with validation errors, you're gonna get errors because the image layout is not great. So we're gonna need to make sure to do that. Otherwise, what else? We also need to actually put these functions into the GPU struct instead of here. And what else? Also, we need to change some stuff around here. Alright, let's see. Render finished semaphores. So, okay, let's do it. So in the GPU, we're gonna have like a function, I believe. Yeah, let's make a pub create function. It would be called, I guess, record commands, right? Self, and here we're gonna basically take a command buffer. So like command buffer, vk command buffer. There we go. And self dot device. So we're gonna reset the command buffer. Well, honestly, we're just gonna basically copy from here this stuff, right? So we're just gonna copy kind of this, right? And here we don't need this, just basically self.device. And we're gonna make sure that this is in safe and that it could actually return a result. Well, anyhow, what the heck I'm doing? This should be here. Anyhow, result, and there we go. Now finally we're gonna say return OK, and what the heck I did here, self.device. There we go. All right, so we don't need this command. So basically, we're going to reset the command buffer. We're going to begin the command buffer and then finally end the command buffer. And here, what we're going to do, we're going to ask the user to give us a callback. So the callback would be, let's call it recorder, I guess. Later on, maybe we could make a class called like command encoder. What do you think? Should we make it now? Honestly, let's just start with this way of doing it, which is basically taking a closure. So fn once, of course, implement. It's just going to be a compile time static dispatch. And here we're going to give it the command buffer. Okay. And also we could give it GPU, a reference to GPU, which is basically self in this case. And I believe that's it maybe for now. So here we're gonna call recorder. Why are you writing your engine in Rust? Talal, welcome to live stream. So I was trying to use like C++ 23, and I kind of basically when I tried my engine in the release mode, what happened, I got a segfault. And I had no clue where that segfault is, even when I used you know, sanitizers. I used everything, because like I was actually debugging that thing, and I've seen that it's kind of corrupting some other place in the memory stack, and it was so horrible. And like of course the syntax really sucks, because like because I'm trying to basically, I found myself kind of trying to mimic Rust in C++ at the end of the day, essentially. Right, using the latest features. And like C++ is going in the right path with its latest standard, but first of all, it's too late, and second of all, it's, what can I say, it feels so bolted in. Like it just, you know, they're cramming all these features on top of another for, you know, backward compatibility basically. And some other stuff like the ecosystem, like people aren't really united on like the same tool chain and so on. So instead of like using cargo in Rust, you're using one package manager, cargo, and you're using what is it called, the same compiler. In C++, you have like 7,000 compilers and 7,000 package managers. Some people even writing their own package manager. Some doesn't even use a package manager, they're just using CMake. Some use make. So there's just no coherence in the ecosystem. Like everyone is rolling their own thing, they're not dependent on like a specific crate. For example, if you want async programming and network programming, in Rust you have one choice. It's Tokyo for asynchronous programming, and you know, Axum if you want web stuff, etc. There's Hyper as the HTTP server. it just everyone is using it, right? In C++, no. Some people are like rolling their own, and like the most standardized option you can find is Boost Azeo, which doesn't have really great documentation, and it's everywhere, and not everyone is really using it, and it's not the best ever. So yeah, there's just a bunch of stuff about it. I tried to adapt to C++ and make it work for me, but I just kind of failed, really. At the end of the day. The drag in your profile picture, is that a Cal Linux reference? Exactly, yeah. I'm getting an address boundary error crash even in Rust now at the point of destroy device. Yeah, because we're using unsafe code, so that's kind of normal. But at least it's not like biting you in a lot of ways. I mean, even like today, I was kind of rewriting some code in Rust, and I figured out that I was gonna bite myself, like, you know, shoot myself in the foot, even inside of unsafe code. It actually told me that I was using a temporary and so on. Since VVL don't tell me anything. What is VVL? Are you using Vulkan 1.3's dynamic render? Still using it? Of course, dynamic render. No way. I'm also using the push descriptors. Though I'm still not even using it because I don't need it just yet, but I'm gonna use it. I suffered through render paths before implementing dynamic render. I do not wish it upon anyone. Yeah, definitely. We're going to be using like modern Vulkan extensions in like most tutorials, if not all of them. Do you think Rust is going to replace C++? No way. No way. It's not going to replace C++. There's a whole bunch of code in C++ that's never going away, especially C++ and C. These, just forget it. Forget it. New code is going to be written in Rust, that's for sure. Most, at least. For example, there's LLVM, which is basically what all compilers are sitting on currently, like Rust, Zig, all sorts of compilers, right? Because it allows you to basically compile LLVM IR to actual assembly code to dozens of, or if not more, like CPU architectures and so on. It's like optimized to death in C++. There's no way you're gonna rewrite that in Rust. I mean, it's gonna take years, man. Not years, decades. I mean, there is some new projects called, what is it called? I think called Crane, which is like a kind of a rewrite in Rust of LLVM to some degree. But of course, there is no way it's going to reach the maturity of LLVM anytime soon. There's also, of course, other projects that are written in C++, like Unreal Engine, for example. There is, it's just not going anywhere. Like, there's always going to be jobs for C++, and there's always going to be jobs for C. There's always going to be people writing C code in C++. It's just not, it's not going to replace it. But especially if you're going to be doing, like, let's say, low-level asynchronous code, you really don't have any sane option other than Rust, honestly, at this point, especially if it's about security and safety. But like in the graphics world, at least, like for example Vulkan and so on, most of the code and libraries you're gonna find in C++ actually. And yeah, BVL, Vulkan validation. I see. All right, cool. So let's go to the next thing. So here we got a recorder. It would be interesting to see a real LLVM replacement. Language developers like the one of Odin or J hate LLVM for its slowness, apparently. Well, it is slow for a reason. I mean, it's doing a whole bunch of like optimization passes, and it's very modular. So, I mean, Zig, in fact, kind of made their own backend, actually, to replace LLVM. But it's only for debug. It's still using, for release, it's using LLVM because there's no way you're gonna reach any closer to LLVM optimizations. And that's why it's slow, because it's just a huge project, a huge code base. All right, recorder that like all languages are dependent on mostly. So here recorder, we're gonna give it self, and we're gonna give it the command buffer, which is, well, the command buffer that we have here. And yeah, that's, I believe that's it. Yep, probably. And of course, just for convenience, we could make it return an anyhow result, so we could make that easier. And yeah, now we're just gonna do this. And now what we could do is in the renderer, instead of doing this stuff, we could remove this code and remove this code, and here we can say just this dot, well actually self.gpu.record commands. There we go. And here we're gonna basically make a recorder, and we're gonna put this code here. And I'm gonna say okay. And closure is expected to take, oh yeah, of course. So here you're gonna take a GPU and you're gonna take a command buffer. And now what? Add expect, yeah. So let's say this. And there we go. So this would make sure to basically like begin and reset the command buffer, and then call the user callback, like this lambda, and then it would end the command buffer, so we don't forget to end the command buffer and stuff. And it just kind of makes it more convenient here. That's the first thing. Second thing here, it gives you these variables directly, which is great. So like you could say GPU dot device here, and then the command buffer is this CMD. Though later on we probably want actually like an actual command encoder really. And yeah, that would make things way... Have you ever built an emulator? Not really. Never, I think. Okay, let's make actually another struct. Why not? Call it command encoder, so we don't have to like refactor this later on. Command encoder. Alright, let's attach to the module or whatever. And here, let's add struct command encoder. And this would basically hold an arc of a GPU. So GPU arc GPU, and of course the command, well, wait, command buffer, right? Yep. All right, so command buffer, vk command buffer. Yeah, that's good. Now again, let's implement command encoder, pub crate. Well, actually not. Yeah, pub crate fnu. And here, what we're gonna need? We're gonna need basically, well, pretty much just GPU and command buffer. And we're gonna return a command encoder. Well, basically self. Return self. And there we go. Next up, let's see what we're gonna need. So here we could have like a function public. Oh, by the way, are you using XCB or Wayland directly in your platform layer or Rust wrapper for windowing? I'm using Winit, which is like the native windowing, cross-platform windowing solution that is in pure Rust. That's what I'm using. It's like, you know, SDL and GFW in C++. Clear image. Let's start with that. And of course, all of these would return like self. So you can chain them. Missing lifetime specifier. Well, of course, let's take self here. Yeah, I think. I recall learning XCB from one of your old videos. Yeah, that is how I got introduced to your channel. Very helpful. Yeah, so the thing is, I was curious about how to not use like a GFW library or like SDL, and I couldn't really find that much resource about it. I hardly made it through using some, you know, fiddling around experimentation and just seeing some weird HTML only text. And once I figured it out, I just decided to make a video on how to do it. Yeah, that's pretty much, it's pretty much like the only video I think about XCB. Right. Consider returning the local behind binding self. Oh yeah, self. And now what we're gonna do here, we're gonna basically take this rendering code that we have here. We're gonna take it from here and take it here. And let's see, so self.gpu dot device, add and save to the, well, not add there, let's add it here in save code. And here what's up, so cannot find the clear color, yep, sure. Let's take it here, so clear color, and it's basically F32 4. That's pretty much it. Now here, give it like the image that you want to clear. Image. So I'm kind of right now just developing my own kind of wrapper, kind of like WGPU, but in Vulkan, essentially, and just, you know, implementing the stuff that I actually need right now. And that's basically it. Now here, self.command buffer. Image layout. I'm just gonna hard code this since this is the best layout anyways. This one though, we may want to change it later on. Or should I just pass it now? Yeah, let's just keep it hard coded for now. What's the difference between enabled extension names and enabled layer names on instance create info? Don't even bother with enable layer names. It's basically the validation layer. Like if you want to enable the validation layers programmatically, you're gonna use the enable layer names, right, to do that, right? But here we don't care about that since we're just using vkconfig GY, you know. And if you want to, you know, enable some validation layer, just do it here. Save yourself the code, right? Just do it here, and you have all sorts of cool stuff that you could do here. For example, you could tell it, for example, enable validation layer, or even disable it, or enable validation layer and do all sorts of cool stuff here. Like, for example, if you click this break, then if there is a validation error, then it would actually break on your code there. I'm gonna actually show it later on, but right now we don't need that. So just disable it for now. But yeah, so only use enabled extension names. It's basically the extensions we're using. Okay, cool. And that's pretty much it, I believe. Now we're just gonna make sure to implement drop here. Yeah, I installed that yesterday. Installed equal accidentally spent hours building all the SDKs. what Arch, like what Linux are you using? What distro? Actually, this one we need to first of all, like, I guess basically begin in the command buffer. Yeah, we could do that. Like here. Wait, what is it called? GPU, I guess. Yep. So I think this part right here, let's take it into the command encoder. And we're just gonna use device, like GPU essentially. GPU.device. And GPU.device. I'm on Arch Linux, got a tar XZ from Lunergy, though it would be pre-built like on Windows and so, but it's started to get cloning stuff in the building. Nah, don't do that. Just say sudo pacman-s vulkan devil. You're not on Windows, dude. You're on Arch Linux. Just say this, sudo pacman-s vulkan devil, and it would do that for you. It would add all the SDK for you. Pretty much. What we have here. Let's make this in safe. There we go. And when this gets dropped, well, of course this should be right now in anyhow results. Oh my god. What's up? Expected. Okay. And finally, I tried searching Vulkan Devil on the package repo, there's nothing. You know, just try it, just try it. Here, I am on Arch Linux right now. If I say Vulkan-Devil, because it's not a package, it's a group of packages, right? So there we go. So there's 11 packages. There's Spurvy tools, there's Vulkan ICD loader, there's Vulkan tools, Vulkan utility libraries, and Vulkan validation layers. All of these would be installed if you install just Vulkan Devil packages. So they're development packages pretty much. And yeah. Now on drop, we're gonna make sure to basically, what is it? GPU, I guess, or what? GPU. Wait. Yeah, and let's grab this in command buffer here, and let's go to command encoder. And we're gonna implement drop here. Implement drop for command encoder. And here we're just gonna basically say self.device and command buffer. Well, basically self.gpu, isn't it? .device. Call and save function, sure, let's say and save. Hey Billy, how's it going? Hello Berisa. We're just doing some refactoring before we go to the triangle stuff. So I made this into a library instead, right? And I basically kind of like, you know, made classes for everything. Hold on, this should be command encoder called, what the heck? There we go, cool. Now here we need self.command buffer. So we don't spend like a week refactoring everything later on. We do it right now. Cannot use the operator. Oh yeah, well, let's just unwrap if something weird happens, I guess. Fortunately. Other than that, we're good. Cool. Cool. I'm new to C++. It's been about 3 months since I started learning language. Do you have any advice on how to become good at it? As I said, the best place you could learn ownership and lifetimes, which also, you know, it's basically just like concepts, also applies to C++ or any other language. You better learn it in Rust. Otherwise, if you just want to go directly into C++, I would recommend learning the crap of RAI. Like, I don't know honestly where to. Is there some tutorial about it? But like one thing that would really trip you over, like when you have a class, you kind of like have copy semantics and move semantics. Make sure you understand those, because that would really F you hard as a beginner, right? Make sure it's like when you define a deconstructor, you have to define some other stuff. Right, so just make sure you go and search that up, at least that concept. Move semantics and copy semantics and other crap like that. That's the first one I would recommend you learn, I guess, to become good at it. Honestly, I don't like. There's a whole bunch of stuff that you have to learn in C++. It's very hard. YouTube chat moderation is crazy. Why? Alright, so we got the command encoder. Great, so this is public. Great, now let's actually go back to the GPU here and see how this would work. So we shouldn't. I'm seeing normal stuff, it's not being sent. Ah, I see. So record commands. Let's actually remove this, I believe, right now. So instead of this way, we're gonna do in the renderer. So instead of right now this, we're using our command encoder class. What we could do, whoops, is say, in fact, we don't even need nsave anymore. In fact, let's remove all this stuff. So we're just gonna create a command encoder, though we're gonna put it in a scope here. Command encoder is equal to command encoder. So did I make it public? Probably forgot to do that. So this would be public only in the engine. So we're gonna say pub create and the renderer here could use it. Pub encoder, new, and here we take in the GPU and we take in the command buffer. There we go. Cannot move, of course it's cloned the arc. And there we go. So now when you go out of this scope, the command buffer would get automatically destroyed. Other than that, right now what you could do is say command encoder clear image. And here the image is our swap chain image. So honestly I'm just going to define it here, swap chain image. Let's define it here. Swap chain image is equal to self dot swap chain images self dot frame, well, image index. Right. This method takes that. So, and let's pass it clear color. It's as simple as that. Look at that beauty. So now any other command we have, we could just basically kind of like chain it here later on. In fact, we're gonna add some few commands. Yeah, in fact, let's do them now so you can see what I'm talking about here. Because, yeah, let's go ahead and do this. All right, so we have the command encoder right now. Let's add another function called transition image, because currently we're not transitioning, we're not synchronizing image layouts, which is not good. It's just working, but it's not great. Right, so let's transition the image from the old state. We're gonna create another struct here real quick to the new state. Now an state, let's see, so transition image state. So this would basically have a layout of the image. So vacate image layout, and some other few things that we're gonna see here. So let's say self.gpu.transition, well, .device.transition. Wait, what the? Oh yeah, we don't have a transition command. Okay, we have to create it, right? Wait, what? No. We have to actually use command pipeline barrier, right? So command pipeline barrier, and should we use synchronization too? Yeah, let's go ahead. So basically there's a new extension called synchronization too. We need though to actually enable it first. Well, we need to enable it. How am I gonna do that? I don't remember how you do it in Ash. Let's see, because we're gonna need dynamic to enable dynamic rendering, buffer device address, and all other kind of extensions anyways. So let's see. So let's first of all actually like close all these tabs. There's a lot of them. And let's go to the GPU. Where we're creating the device. Yeah, we're creating the driver. Okay, fine. And let's see what we got here. So we kind of basically need a P next here. Oh yeah, we have push next. Yeah, I just remembered. Okay, so let's use that. So push next. And here we could say mutable vacate physical device features, though I don't remember which Vulkan version. Let's try Vulkan 1.3 features and synchronization. Yeah, there we go. Synchronization. Let's enable this feature. This extension. I mean, it's already enabled, and it comes with Vulkan 1.3 anyways. Distro CachyOS based on Arch Linux. Okay. And we also want to enable some other things like dynamic rendering. And what else? I'm gonna use what else? So here you could basically find all the Vulkan extensions that are already included in the Vulkan 1.3. So you don't have to like enable them by adding them in the extensions. If you're using Vulkan 1.2, then you have to add these extensions before you can enable them. Right. Well, the other thing is that I'm gonna need to add the dispatch tables of these. Oh my god. Well, I wonder, so I want to basically enable push descriptors too, but I'm not sure if I could use like Vulkan 1.3 features. I mean, I have to like actually add those extensions anyways, but if I can use that struct at least or not, I'm not sure. Can I use Vulkan 1.4 features struct in Vulkan 1.3? I mean, I know, I understand this, but can I just use that struct? Can I at least use the... Or should I use those extensions? Use the microphone so your hands don't do all the work 100% of the time. It's way faster when using. I'm just used to typing. It also makes me like think about how I want to structure the question, but I actually should try that more. Yeah. Short, punchy truth, no. In a Vulkan 1.3 app, you should not stick into your PNX chain. That struct is only valid when you're actually targeting 1.4. You must use the extension-specific feature structs and enable the matching device extensions. Why? This is the law of the land. It's defined to describe Vulkan 1.4 features using it applies a 414 API contract. I see. I see. So basically the thing is, for example, here I'm using 1.3, so I could use this 1.3 features struct that basically contains all the extensions that are core in 1.3. So I don't have to like have one struct for synchronization to and another for dynamic rendering. I'm using Vimotion in Firefox and doing FDW will trigger the microphone, then F plus another combo will confirm it. So no mouse required. Made my life so much easier. Recommend. Yeah, Vim, I can't just... I mean, I kind of learned some few things about Vim, but damn, dude. I just can't get it over. Like, there's just a lot of friction. It needs a lot of time to learn. Screw the distro, screw the program language, screw the package manager, screw graphics API. Where's your keyboard? My keyboard is a regular HP keyboard. I do have another one here that is like a mechanical one, but I don't use it. But this is just a regular keyboard, yeah. Okay, so yeah, since we're not using 1.4, let's just do it. So I want to enable the push descriptor extension, which would make our life way easier than even the WGPU and OpenGL people in terms of screw you. Okay, so let's go to push descriptor, Vulkan feature struct. Or I mean, you could probably find it here though. So let's say push next again, and mutable vk physical device push descriptor. Is it this one? Or maybe just like push descriptor. Huh. Yeah, I'm not sure. Let's see. Ah, there we go. Properties. Physical device properties. Okay. So physical device properties, KHR, isn't it? Well, push descriptor, I guess. There we go. So this one. And then I basically say, but wait, what the heck? Really? Max push this, what? Extending device properties, but like there needs to be a way to enable it here, no? Max push descriptors. You know what? Let's ask ChatGPT here. So this is what it's doing. How to enable push descriptors in Vulkan 1.3 using Ash. Let's see, because the thing is, if I were using Vulkan 1.4, I would be able to just do similar thing like I've done here. And since I'm not, unfortunately, we have to figure out the way to. So in Vulkan 1.4, but like if it's not there, then why they have it? Wait. Why have it then? Or isn't it? No, they don't. What? I'm confused. Yeah, no, there's no 1.4 anyways. I see. Bro, what the heck? Enable the device. So I just enable it or what? Cord KHR push calls. Exactly, in Vulkan 1.3 you only need the device. There is no okay. So that's why. Okay, fine, gotcha. I understand now. Alright, cool. So alright, let's go back to where we're creating the so here, enable the extension name. So here we add it. Okay, gotcha. So KHR push descriptor name as BTR, because it's not a core extension in and since it's not a core extension in Vulkan 1.3, I also have to kind of do something similar to swap chain, unfortunately. Which is where is that thing? Oh yeah, I'm doing it in the GPU though. So for the GPU, I'm gonna basically add another dispatch struct. Where is it? Here we go. So adding this, let's add it here. So we're gonna call this push descriptor extension. Ash KHR push descriptor device. So this would load the function pointers of this extension. If it was core, we wouldn't have to do this. It would just be there, you know. Unfortunately. But anyways, so now let's see how we're gonna add this. Swap chain extension. Next up, we're gonna need the help of the driver again. Okay, cool. So here we need the push descriptor extension. Driver.load descriptor well, push descriptor extension. And whoops. Okay, now let's check this out, and we're gonna do something similar to this, just for push descriptors instead. Right, now instead of swap chain, I'm gonna go with push descriptor. I'm gonna do similar thing here, and there we go, same thing. Perfect. Now this should be public, I think, or isn't it? I mean, it already is. Oh yeah, there we go. And now just add it, and there we go. Now we load it. Is there any other extension I'd like to use? Yeah, I'd like to also use so basically I want to do vertex polling. So instead of like OpenGL, you tell OpenGL what kind of format your vertex struct is and so on. I want to later on just basically just do that only in the shader and in my code, not like telling it what kind of format it is exactly, and so it really sucks that way. So it's called vertex polling. And for that to make it easy, what we're gonna do, instead of having descriptors for every single buffer, we could also use buffer device address extension, which basically allows us to get the pointer to the GPU buffer directly instead of messing with descriptors every time. And for that, we're gonna need another extension, which I believe it is core in Vulkan 1.3, I believe. Though these extensions kind of make debugging a little bit harder, by the way. So that's one thing. Like for example in RenderDoc. But other than that, we're good. All right. So where are we gonna do this? We're in the GPU, of course. Let's go back to where we're we're creating the device. Oh, we're actually doing it here. Okay. So is there like a buffer device address here? Oh. Is it like in 1.4? I guess so. I mean, let's check it out real quick. Well, actually this one. And let's see, did it get, yeah, promoted to Vulkan 1.2. See, so I could actually use this way, but I need another one, which is for 1.2 here, 1.2. And now I could enable all the extensions that I want here. So buffer device address, there we go. True. What are you using the synchronization 2 for? Just some better calls, some better synchronization stuff, like the pipeline barriers, if you know them. You're gonna see in a second. We're actually gonna be using them really soon to transition the image layout. Other than that, I may actually try to experiment with, you know, what is it called, bindless later on. I still didn't wrap my head around full bindless yet, but we'll see how it goes later on. But for now, I think that's the only extension I need here. Yeah, probably. There's also scalar block light. Yeah, this one too. So this one would allows us to not give a crap about like the vertex extension padding and so on. It's just gonna be packed, which may affect performance, but I don't care, honestly. It just makes development way easier. Like, you're gonna see the ergonomics is gonna be crazy. Other than that, is there any other extension I want to enable? I think, of course, you should have these extensions on, otherwise this would fail. Yeah, timeline semaphores. I also want those at some point. Timeline semaphores. Is there anything else? If you guys know any interesting extension, please let me know. Yeah, I think that's pretty much it for now. Yep, pretty much. So these are the ones that I'm gonna be enabling right now. And of course the push to scripture extension. All right, cool. So can we make sure at least it's, oh well, hold on a second, what's going on? The type cannot be indexed by a U32. Oh yeah, as U30 as U size. And let's try this out. Let's make sure everything's working currently. And what? Let's see what's going on here. So clear image. Like, is there some error or something? Wait, let me actually run vkconfig gy real quick here. We're gonna say any running Vulkan executable validation layer, and we're gonna say break here, and we're gonna click on debug, and then it would crash directly where we have a problem. There we go. So as you can see, when you actually enable this one does a lot of people doesn't know about. It's very useful. So when you check this break, like when there's gonna be like a validation message, it would break right into your code and tell you exactly where the error happened. So it happened in acquire next image khr. Why? It happened because the fence submitted in signal C must be reset before being submitted. Huh. We're resetting the fence though, right? What? Self frame index 0. Huh. Wait a second. Let me just make sure this is the first frame we're talking about. Yeah, it's the first frame. And it's... Well, first of all, I had a problem in the last video. First, I'm not sure why it worked with it. Is that we don't want to actually pass any fence here. Just pass a null handle here. That's the first thing. Is that... I don't think though it's the problem, because it was working before without it. The next thing we have is wait DSG stage mask is null. Okay, let's fix that real quick. That's also something I had forgot. So we're gonna basically go to, well, just tell me where exactly real quick. Yeah, so here I have the call stack, and I can go back and see where this is being called. So here, let's come here and let's add the wait signal thing. See how much like the validation layer is very useful. Like you just, one button, you enable it, you do whatever you want. When you're done, you disable it, boom, done. No code changes, no nothing. It's just magic. Right, so here, vk pipeline stage flags, right. This is one thing I actually love about Vulkan. It's validation layers. Like you can't find this in DirectX nor OpenGL nor WGP. You could use it because, well, it's just using Vulkan under the hood, but it's not as good, I guess, because the Vulkan code isn't your own, so it's kind of hard to debug. Either way, here we only need transfer. So this is kind of basically set it to the first stage you're going to use. Synchronization is kind of hard. I'm going to try to explain it later on once we get into it. But let's right now just fix the problems that we have here. And yeah. But why it is black though? Wait a second. Why? It should be red. Unless if I forgot something. Oh, I just remembered. Alright, so we still have that code. Ah, yes, so there's nothing wrong with my code. Yeah, so like in the application, clear color function, we have this code, yeah. Gotcha. We could flip it to make it white, just to make sure that everything is working correctly here, because black, yeah, so yeah, it's working actually. I just thought it wasn't working because we had red before, right? So right now we don't. Or we could like make this 2 windows. Oops. And we're gonna have a black and white window, which is great. So do I have any validation problems right now? Yep, look at that. We have a problem here, which is that. In fact, let me debug so it would basically break there. So I could show you where exactly that's happening. And there we go. Oh, actually, why it doesn't, did I disable that? I probably did. Where is it? Break. What? Oh, here, it's here. It's actually enabled. What the heck? Really? That's strange. It should break there. I'm not sure why it doesn't. Either way, it's fine. So here's the validation problem. Here it told us that in the VKQ submit, let's see where we're doing the VKQ submit. We're doing it here, submit command buffers, right? So it told us that command buffer, and this, expects a vk image. So it's talking about the image here that we're using, which is our swap chain image. It said that to be in layout, vk image layout transfer DST optimal. Because you remember here in the clear color, like in the command encoder class, here this clear color image command expects the image to be in this layout, transfer DST optimal. But what the current layout is, vk image layout undefined. The vulkan spec states if a descriptor with type equal to any of this and that and so on is accessed as a result of this command, all image subresources identified by that descriptor must be in the image layout identified when the descriptor was written. Either way, all this philosophy just to tell you that this image should be, before you use this clear color image command, it should be in transfer DST optimal instead of undefined. It's pretty important to be able to read the validation errors because, yeah. All right, so here, let's see what we got. So here right now, we could actually use the synchronization too. So self.gpu.device. Here we're gonna make a pipeline barrier. So CMD pipeline, and since we're using synchronization 2, we have to use this instead of this. So this is like the new version of that, right? Here we have command buffer. And here we got dependency info. Whoops. I thought I was in C++ for a moment there. Here we got buffers, images, like we could use this for all sorts of kinds of resources. But right now we're interested in images. So we're gonna set an image memory barrier. So this is what we use for synchronization. So what this needs a slice. So like you could actually specify multiple of these, but for now we're just going to use one of them. Image memory barrier 2. Whoops. Barrier 2 default. And let's see what we got here. So first of all, of course, the image that we are talking about, which is basically image. We should take it here as a vk image. Notice basically here I'm just kind of like abstracting the gnarly details of Vulkan into one little function that we could reuse. Okay, cool. So what we need here, old layout and new layout. So first of all, you tell it which layout you were in, old.layout, and then, because like Vulkan isn't tracking the layouts for you, you just have to tell it which layout you were in yourself. So new.layout, you have to be explicit. So next up we have, like later on maybe we could try to make like a render graph, which isn't an easy task, which would basically do these transitions for us automatically instead of having to do it ourselves. But for now, this is what we got, right? So the first thing is the SRC stage mask, and we also got the axis mask. So let's actually store these here together. So stage mask, what's a render graph? So as you can see here, basically when we want to, let's say for example, use this clear color image, it is expecting the image to be in this specific image layout called transfer DSC optimal. Now, so to be able to use this function, we have to basically make sure to transfer the image layout ourselves to the correct layout using this CMD pipeline barrier 2 function. But like if you make a render graph, you could basically make this particular thing automatic. It would handle this layout transitions for you. That's the first. And also some other synchronize. So like all the Vulkan synchronization would be handled for you. A render graph is basically a graph telling, describing like what resources depend on which other resources. What can I say? So like, for example, what can I say? So presentation, for example, is depending on inputs, right? The input is basically the rendering to be finished, and the rendering to be finished is dependent on the image to be acquired and so on. So basically you describe these dependencies, these resource dependencies in the render graph, and the render graph is supposed to see those inputs and outputs and basically emit these pipeline barrier synchronizations itself. Like it basically would infer that itself because they have the whole graph on inputs and outputs, and it can figure out what it needs. So we don't have to do it manually. But for now, since we don't have a render graph, we have to do it manually. Volcano, though, by the way, actually did implement their own. In fact, I could show you in Volcano, really. Let me show you. Volcano did implement, and it's actually a very recent feature they have added. Let me show you examples. And I was impressed when I've seen it. Where is it? I believe they had some example here for that. So it's not Vulkan thing, it's a user. Yeah, exactly. It's a user abstraction over Vulkan, right? In fact, not even Vulkan. Like you could use it for direct. You need it for DirectX, and you need it for all sorts of stuff. But either way, let's see. I believe ray tracing. Maybe they used it. Currently using Vulkanalia. Let's see if you make me regret. I've seen Vulkanalia before, but I don't know what I had thought about it, honestly. I don't know. I thought it was like not. Oh, it actually still maintained. Interesting. I'm not sure. Like, how is it different from Volcano though? I'm not sure. Like, how is it different? Oh, they also have their own VMA integration. That's cool. Offer a fairly thin wrapper around. Let me see some code. I've seen Vulkanalia before, but like I thought it was not even maintained anymore. Let's see if I could figure out real quick what's the difference. So far it's just like regular Ash code, I think. It's not very clear like what they're changing here. Weirdly enough, they seem to be using like maybe an old Ash thing, or maybe they're creating their own builders for some reason. Wait. Where Vicky coming from? weird. I don't know. I don't really see the difference here, honestly, too much. Yeah, I don't know if you know some difference other than like just raw Vulkan. Doesn't seem that different to me so far, at least. Yeah, it really doesn't seem far like from Ash. Unless if I'm missing something here. How do you even get into this level of autism? I don't know. Hello, welcome to livestream, Xlobby. Reset fences, queue submit. Swap chains, image indices. Yeah, I don't know. I don't know what's the difference. So I can't really tell how good is Vulcanalia here. But yeah. Either way, let's go back into this. So for example, the ray tracing, I believe I've seen a render graph there. Render graph. Yeah, there we go, a task graph here. And what is this resources? Self.resources. Oh, there we go. Okay. So here they have a render graph abstraction. So like we have a task node called scene of type graphics. Apparently, scene task, new virtual task. So I probably, wait. Image access. So here you kind of like declaring, like I guess here the layout image that this particular task would need and the access type and so on, and then it would basically figure it out itself, the synchronization it needs. I'm not sure exactly, but yeah. Either way, let's go back to business here. Let's go back to business. Right, so what we got here, calling and save function, let's say and save. What's going on here? Oh yeah, so we had stage mask here. So let's say pipeline stage flags 2. Make sure to use the second one. And then access mask vk access flags 2, since we're using synchronization 2. Other than that, let's see what we got else. So old layout, new layout, and then we have src access mask, old access mask, and src. Well, honestly, let's do the src stuff with the old layout, really. And the src stage mask, old.stage mask, I think, yeah. And here we're gonna need to, well, honestly, let's just copy this and paste it here, really. Old.layout. So here, instead of old, we're gonna say new, new, new. Other than that, we don't care about family indices here. We're using 1Q, which is the first. And finally, I guess the sub-resource range. So like which, right now we're just gonna hard code this one, honestly, until we need it. We're gonna need it later on for like the depth, but we'll see. Forgot to change second old layout. Oh yeah, thank you so much. New layout. And DST stage mask. DST. I copied and pasted and forgot to change these. Yeah, thank you. All right, so let's see what we got here. Default dot layer count 1 and dot level count 1. The other ones we're gonna leave them at default. Well, and there's another one that we need here though, which is the aspects mask. We're just gonna hard code it currently. Color. Yeah, there we go. Someone said, like, programming Vulkan is like filling forms. This is exactly what it's like, but like this is just the start, so we're still like creating our own little abstraction. But after that, you know, other new tasks would become easier and easier and easier. Right? Since right now, this is why I'm making all these abstractions, so I don't have to like fill out all these forms later on. We just do it at the start, but later on we just call one function transition image, and it would do the job for us, essentially. So type is more private. Let's make sure that this is public. So at first we just kind of have to basically abstract the details we don't care about, you know, and then later. So here, transition image, the only details we care about, we've put them in parameters. The others, we just hard-coded them for now. Later on, when we need any other details from here, we could actually just put them in the parameter and put them here again. Other than that, we're good. So now let's go back into our render, so to use our new shiny transition image function. Let's see. So what was it? Yeah, I think here, right? So command encoder clear image. So before we clear the image, we have to transition the image. And oh, I forgot to do one little thing here in the command encoder, is that every time for every command, we're gonna return back a reference to self. So we could chain commands, which is very nice. So to chain commands, we're gonna basically return self. And that, what that allows us to do basically like this, right? So we chain commands like this, which is very sick. Right, lovely. So this is what these abstractions are all about. That's why I'm typing all this crap. Yeah, pretty much. All right, so here we can pass in swap chain image and then image state. Image state, and here we're gonna fill in this little form. How are we gonna do this? Well, so first of all, the layout. So image layout. So the old layout is basically none. Wait, what the heck? Actually, basically in defined, yeah. In defined. This next thing is stage mask, which is basically pipeline stage flags 2. And right now we're gonna have none because we're just starting out the actual commands, and the access mask none too. Okay, access mask. What? Access flags. Okay. To none. Well, this thing honestly could go into a little function, but anyways. So what's up? What's going on here? Oh, they're private. Well, actually, these would be public though. We may make them public. I'm not sure. We'll see about that. Alright, so that's good. This method takes... Alright, that's good. Next up, we're gonna make another image state for the new. So this is the old. In the find none. Now we want to clear the image, so we're gonna make sure that we transition the image to transfer DST optimal, which this clear image needs. And the stage mask of this clear image, since it's a transfer command, we need to make it transfer stage. And the access mask, since this clear image would write into this image, we want to make sure that the GPU is ready for writing. And the color, I believe, attachment, actually, wait, no, transfer write, there we go. So that's basically how you do a transition. After that, after we're done with clearing the image, we know that we're gonna basically present that image afterward, which means that after we're done with this command, we have to transition the image again from this state to another state here, which is basically transfer, well, basically here present srckhr stage mask find transfer. I mean, presentation is kind of like transfer 2, I believe. And actually we could here just say, I think probably none, since we're done here, and transfer right, maybe none. Alright, so just make sure that the layout is present srckhr. That's what's important here, right? And that's how you pretty much do it. Right, defined none. Yeah, so this is basically the same state here, right? So like you could even do it like this since we made it struct. So clear state is equal to basically this. Now we could track them ourselves, but that could easily shoot us in the foot later on when we do some more advanced operations. That isn't very clear how to track those states. But yeah. And honestly, this clear state function, sorry, this image state, we're gonna make it clone and copy, which means that it's cheaply copyable. So we don't have to clone it every time we reuse it. And there we go. So as you can see, just make sure that the new layout here is here and the old one is here, basically. And this one, honestly, we could even make we could do something interesting here, which is we could implement a function here inside of image state called none, right? And that would basically give us back an image state. And there you go. Now, instead of doing this, I could just say image state none, basically. And there you go. Now here, this is for presentation. Same thing with presentation, honestly, nothing fancy about that. You could just, I guess, copy this and let's go here. Public create fn present state self image state. And there we go. Image state present. There you go, much cleaner. Look at that. You know how much like the actual Vulkan code would be like without this abstraction. So it's really this simple now. So we transition the image from none to a clear state. Then we clear the image. Then we transition the image from clear state to a present state. And honestly, the clear state, we could, yeah, fine. Let's make a function for that too. Why not? And so this is kind of like presets, presets in some sense. So clear. And now we could just remove this. And here we could just say image state clear. So if we had like a render graph right now, we wouldn't need these transition image functions. It would just do it for us, essentially. And yeah, that's basically how you do the transitions correctly. That's great. Let's try this. It shouldn't change anything. It just makes sure that the validation layers doesn't yell at us anymore. But we still have another problem in terms of synchronization. Which is like, this is a new validation error, I believe. Yeah. So basically, most of the tutorials are going to find out there, and even most engines, they're going to be having my setup, which is that like you have these image acquired semaphores, render finished semaphores, and in-flight fences. These are called in-flight fences. But these aren't enough anymore. So like there was some guy who had some advanced case, right? And this setup, simple setup, caused him a deadlock or something, if I remember. There's a GitHub issue about this. And basically the validation layers, recently they changed that so that it makes sure that it detects. So it's became more strict essentially about this point. So you kind of gotta change the code a bit here. And honestly, here's how you do it. So you basically need to keep track of which in-flight fence for each image, swap chain image. We're not going to be creating like new fences. We're just going to keep track of which fence last time owned the image in some sense. Let me just show you. So here we're going to say swap chain image fences, right? And this would contain, I mean, fine, vec fence, right? And so how are we gonna do this? Well, let me show you. Wa alaikum assalam, Ujigir, and welcome back to the live stream. So here, by the way, let's call this in-flight fences actually. So we could remove this from that, right? And let's make this swap chain fences. And this ones, we're not gonna create new fences. We're just gonna create them empty fences, right? So here's how we're gonna do this. We're gonna basically say 0 to 2 dot map. Right, and we're gonna say vacay fence null. In fact, maybe we could not really, no. So just this way. So we're not gonna create new fence, just a null empty fence, and we're gonna collect. Though we don't need any result here, since we don't have any result, we're just gonna say vec. What's going on here? Yeah, we don't need that. And there you go. So just empty fences. Right, cool. Now, what we're gonna do is, after we acquire the image, where we're doing that, yeah, here I believe, yes. And after resetting the fences, we're gonna say basically, if we have some fence that is like, if this image is owned by some current fence, how are we gonna check that? Well, if self.swapchain image fences not equal to vacay fence null. What? No. Here we're gonna say self, like we're gonna use the image index here, right? Actually, yeah, by the way, this shouldn't be 2. This should be the swapchain images count dot size. Alright, so how do you get the size though? What is this swapchain? It's a vacay. How do you get it in, I guess, len? Yeah, in Rust you say len. There we go. Or honestly, too simply here, what you could do instead, just swapchain images.iter. Yeah, fine. You could say just iter here, and yeah, there you go. That's cool. And now, image index as usize. So if it's not equal to vacay fence null, then we're gonna make sure to wait for that fence to finish, basically, before we proceed. So we're gonna do something similar to this, but using this guy here. So let image fence is equal to this. So if image fence is not equal to null, then we're gonna wait for that fence. That's basically what we're gonna do. After that, we're gonna make sure to actually set up this. So how are we gonna do it? Well, wait, can we do this? Right, and here what I'm gonna say is image fence is equal to the current in-flight fence, which is this. Yeah. Now honestly, I'm gonna store this here so I don't have to like do it every time. My last company had this weird phase where we moved away from using anyhow. Probably felt like how this makes you feel. Yeah, I know. I did mention that I want to move from anyhow, but only for the library, not the executable. Anyhow is basically best used for executable where you don't truly care for most errors. You just want regular string messages, right? But for libraries, like for example, my engine is a library. I should later on like change this from anyhow to this error, to another crate called this error. Yeah, we're gonna do that at some point, probably maybe even today, I'm not sure, we'll see. But we should use this, which basically gives you more information about what actual error happened. Yeah. Yep. Yes. That. Yeah. Exactly. So like all libraries in Rust use the same crate for most stuff, which is really an amazing thing about Rust. We're just like very united. So yeah, that's pretty much. All right. Let's see how we're gonna do this. Equal to in-flight fence. Yeah, let's make this mutable, I think. Mutable. Can we? Right. Yes. So here, as you can see, we're not creating a new fence. We're just pointing to another existing fence. It is really relearning a similar C++ library even a second time gets tiring. Yeah, that's pretty much it. Yeah. So like every single project is reusing another library for the same task or even rolling their own, which really sucks. In Rust though, if you're talking about async, it's surely Tokyo most of the time. If you're talking about images, it's image. If you're talking about serializing and deserializing JSON and so on, and XML and stuff like that, you're talking about Serde. If you're talking about errors, then you're talking about anyhow and this error. Like everything is pretty clear. Like the ecosystem really agrees upon a lot of crates, which is amazing, lovely. And honestly, the easiness of cargo, like you could easily add any crate, like cargo add, insert the name here. It's really making people adopt libraries easily. And like in C++, which is a mess, there is VC package, which makes things a bit easier with CMake and so on. But to get to a point where you're very comfortable with adding libraries in C++, it's a big achievement. Right. Anyways, so let's see what we have here. So that's pretty much it. And of course, after waiting for the fences, you gotta also make sure to reset the well, actually no, we shouldn't reset the fence though. And then wait 10 minutes for cargo to install the fence. I mean even in VC package they do the same thing really. And if you want debug information, then you gotta do like compile yourself Qt and other libraries. Which is even worse, since at least in Rust though, like most libraries depend on the same libraries for the same task. Like for example, let's say you have two libraries that you're depending on, A and B. They both need image loading stuff and so on, and image decoding. They're gonna be using the same library to do that, which is image. So it's gonna be compiled only once. Not like every library would pull like its own image kind of library or so on, which is great. Internet and CPU issues. But yeah, either way, I think we're done pretty much here. We shouldn't though reset the fence. That's not our job here. We're just making sure that we're not stomping on an image that is already being used by someone else. I think that's pretty much it. Yeah, let's try this one. I guess we don't have any validation errors, right? Oh god. We do. Well, it's being signaled by VKQ, but it may still be in. What the heck? Though I think we also need another thing. Yeah, it's very annoying, very confusing, this kind of new change of validation layers. But I remember also render finish should also be the same thing, I believe. Image acquired, no. Render finished. Where is render finished? Here we go. So this should also be the same here. So render finished. Gonna do this instead, not the in-flight stuff. I really wish we could get something closer to CMake from Rust. I have a lot of nitpicks with regex, but that is true for any place using regex is hell. I hope it gets through. I wouldn't use regex for parsing. I would use combinatorial parsers, I think, or I don't remember what they're called. Parser combinators, right? These are very cool. They're like iterators, but for parsing. And in Rust, I don't remember, there is a crate that does that. In fact, I did make a video about it before. I made the scripting language using it, which was very fun. There is num, though this is not very ergonomic. There was another library that I actually used there. Not num. There was another library. I mean, num is kind of something, but I mean, I used it here really in my video. Wait. Did I mention here the... It's pretty nice, like when I actually search for something like very obscure and I find only my video. It's like crazy. Right. There we go. It's called Chomsky. It's called this is a very nice library for parsing. Very nice. Like the best library I could find for parsing stuff without losing your mind. Yeah, there we go. Create Chomsky. Chomsky is a parser library for Rust that makes writing expressive, high-performance parsers easy. So it's basically functional programming, but for parsers. And also it comes with another crate by the same author that really had this cool, like, diagnostic errors. Look at that. Beautiful. It's like, Mom, I'm on TV, but it's someone Google's. Exactly, yeah. Yeah, there we go. So RA and A for like errors. There we go. So this is it. Yeah. All right. So for example, this library, sorry, not the language brain fog. This is how you make it in using this language. You just like create an enum called instruction for left, right, increment, decrement, read, write, and loop, which is basically a vector of instructions. And then what you do, so this is how like you create a parser. So this parser could actually be used, they're blocks, modular blocks. Like you have one parser using other parsers essentially. Like for example, just here is actually a parser itself and so on. So, and yeah, but either way, so to parse brainfuck, what you do is you have a recursive parser. What about tree setter? I don't know about tree setter, but I don't think it's as good as this library. This is like the best I could find for parsing without losing your mind. So a recursive expression, right? So you have a choice between either just this token, this like character, and if we find this character, then we're going to convert it into an instruction left, right? If we find this, we're going to convert it to right, and so on. This is for increment, plus, minus, decrement, comma, read, and dot to write. And then, otherwise, we also got lists. So this is how we're gonna basically parse lists. It's basically BF, which is like the recursive thing, right? Delimited by just this, comma, just that. Then map instruction loop. Right, so it's pretty expressive. Oh my god. So like you can't really make it any better than this, like for real. And then you repeat this a recursive thing and then collect the result, and there we go. Now you can parse brainfuck language. Really that simple. And there's some other examples. Like if you're really interested into seeing how this works, you could look at my video about this. Yeah, it's very good for parsing. Like if you're gonna do parsing, you make your own language, then please just save your mind and use this. It's very good. There's even a nano Rust example. Like this is they're basically implementing a basic parser for a Rust kind of like language. And here we go. So you have token and so on. And like for example, if they want to parse a number, they have a text integer of base 10, then just a point, then just text digits 10 or not. So this is like dot is optional. So slice from stir in wrapped, and then we map it into a token num. Yeah, it's very nice. Like for example, operator here, one of plus, minus, or des repeated at least once. You really can't get better than this in terms of parsing, like for real. will 100% look into this. My work really intertwines with Linux, and there will never be a day I will 100% avoid it. However, even avoiding it 60% would be like in a free air translate. Like for real, if you're gonna do parsing, save yourself, use Chomsky. You could check out my, as I said, my tutorial about it. Chomsky parser combinator. I think my tutorial would show up again. Yeah, here we go. Check out this math expression parser or this video functional parser. Let's make a scripting language. Check out my videos about it. It's pretty good. Other than that, let's go back into business here. So what we had. Let's see. So basically we changed this to Dutch. Render finished, image acquired. All right, then here basically where we're using the render finished semaphores, and we're using it here. So instead of using frame index right now, we're going to use the image index. There we go. Render finished. We gotta use it here too. And please tell me that there is no validation errors this time, because there's no way. I have no clue what else that could go wrong here. Yeah, I think he maybe worked actually. Why not convert image index to usize? I am converting it to usize. Oh, you mean like in the here? But well, there's this destructuring thing that I don't want to deal with. Though, yeah, I think it works right now. I think we don't have any validation errors. Other than this is just because we're not destroying stuff properly just yet, which we're going to do in a second. But I just want to make sure that we have no errors for this part, which I think we don't. I mean, so far, I don't think we do. Yeah. Finally. Right? Yeah, we have no errors. Perfect. So we fixed the synchronization. Great. Next up, so we have 2 left to fix this mess, to get a pristine clear color window with no errors whatsoever, which is, first of all, resizing the swap chain properly. So we're not handling that yet. We're not handling resizing the windows yet properly. That's the first thing. Second thing is actual 20 minutes is an out adventure. In an out adventure. That's the first thing. The second thing is destroying things properly. What should we start with? I guess let's go maybe with destroying things properly. Or no, let's go with resizing stuff. Alright, let's see how we're gonna do this. So basically, when the windows get resized, we want to destroy the swap chain or create a new one and get the new swap chain images. And that's essentially it. How are we gonna do this? Let's see. So basically, first of all, we're gonna go to our clear color here, and here when we get a resized event, like resized, here we're gonna get like size, or just size, right? And here what we're gonna do, we're gonna resize that particular thing, and we're gonna basically delegate that to the graphic subsystem of the engine. So as immutable dot inwrap dot resize window, and we're gonna give it the window ID, and here the new size dot inwrap. I believe that's basically it. Now we're just going to create this resize window function. Whoops. Let's create it. So let's go to our graphics. Our graphics here, we're going to create a new function. pubfn resize window mutable self comma id window id comma the new size. So the new size would be, I believe, yeah, vk physical. Well, we don't want that in our engine, so we're just gonna honestly take dirt, an array essentially. And so let's go back to actually to our clear color example here, and let's make this, let's say .into, so it converts it into an array. And let's go back here. Right, so here now we're gonna delegate that to the renderer object. We're gonna do something similar to this, but instead of render, we're gonna say resize. And we don't need a clear, we need a size actually. And now we need to basically create a resize function inside of our render class. You see, we're kind of like traversing the whole abstraction layers. Right. So everything is responsible for something else. All right, so here we got like pub create fn resize, and it's gonna take like a size u32 2. There we go. Now for the resizing, we're gonna basically recreate the swap chain. We have this GPU create swap chain function, which we're gonna use. So let's actually just copy this. Same thing with this, in fact, yeah. Self, well. So these are like the new swap chain and the new thing there. Now we're basically gonna replace the old ones. Well, this needs to be mutable though. Right, and the new extent, the new size. And here we need a result though. And there we go. Now here's surface, self.surface. And here's self.swapchain. Though of course we need to make sure to destroy the old one. And for that we're gonna use, I believe, the GPU again. We don't have a particular function for that yet, so let's actually no, self.swapchain extension, I think. How do you handle those absurd displays like 3:2 ratio my friend has? Like in what exactly? In GUIs or what? Here we're gonna, well, I need basically the swap chain extension here. And then I could destroy the swap chain. And the old swap chain here. And there we go. Yeah. Well, for that you just use, what can I say, layouts. Instead of like hard coding pixels in, like for example in Roblox, like it's the easiest, simplest one. You kind of just have, like for GUIs you have two things, like actually you have 4 values. You have X, Y, Z, and W, right? Like this is basically, for example, let's say the size, for example. And you also have like another values though, but let's talk about these first. So like you have these first, which is the absolute, actually no, the scale. They're called scale. So like scale X, scale Y, and then here you got the absolute offsets. So right, offset X, sorry, offset Y, right? So these offsets are in regular pixels, right? But the scales here, they are percentages of the window size, right? So for example, let's say I want some GUI panel that would take full screen. What I would say 1,1, so basically 100% scale X and 100% in the scale Y and 0 in the offset. These are the raw pixels, right? Let's say I want the whole size of the window, but minus some little pixels, some margin, let's say 8 pixels. So I would say minus 8 in the offset. So these are the actual pixels. So this basically means 100% of the screen size, like 100% of the window size, minus 8 pixels in the Y and the X. That's basically how it goes essentially. And you have something similar to for the position. For the position, let's say you want to position it in the center of the window. How do you do that? Well, you basically use for the scale, you use 0.5, which basically means 50%, and then 0 in the absolute pixels. But you also have another values called the pivot point, right? So this is like from where you position your stuff. So like here 0.5, 0.5, by default it's going to be 0, 0 here. And these zeros basically means that this position would apply from the start, from the start of the window, right? So you're basically positioning stuff from the start of the window. So for example, it's actually clear in the size. So if you say, what can I, So let's use this, okay? So we have here this. So this is the pivot point 0, 0 and half of the screen, which is like 0.5, 0.5. Now, if we change the pivot point to 0.5, it would start positioning stuff from the center of this thing, right? So it would basically, if you have 0, 0 position, it would go there, right? But if you have it here, 0, 0, 0, 5, 0, 5, then it's going to go here. But yeah, hopefully that kind of gave you a little idea of how do we do that in a like a regular level. Though like in CSS, for example, you use kind of layouts, right? So you have a vertical layout, horizontal layout, grids, and so on. But that's kind of like the fundamental thing on how we handle multiple screens and so on. Either way, let's go back to business here. How are we gonna do this? Well, regularly we actually gonna put these functions into the actual GPU, but for now we're just gonna do it real quick here. Make public, destroy the swap chain, provide the argument, none, and there we go. That makes sense, yeah. Alright, cool. The swap chain images, we don't own them, so we don't need to actually destroy them though. So that's great. Other than that, I think we're good, right? Yeah, I believe so. After that, we're just gonna make sure to say okay. And that's basically it, I think. Yeah, I'll just make sure that whoever is using resize is actually propagating back the error. Who's using resize window? Yeah, good. So now I think we're handling that, which is great. So like resizing the window would make sure to, whoops, what's wrong? Invalid wiki image objects. Huh. Also another thing, by the way, before we resize anything, we gotta make sure to wait for the GPU to idle. So wait idle, idle. I remember I had a function here though for it. No? I don't know. I remember, but I think maybe it's just like not public or something. Yeah, I do remember I had the function for it. Here we go. What? Wait, let's go to GPU, wait idle. Ah, we just like calling the device function directly. I see. Later on we should move that to the GPU, but right now let's just, yeah, do it. GPU device wait idle. So we basically have no synchronization issues. We wait for the GPU to finish its job before we destroy the swap chain. Other than that, let's add an insave function here. And this could fail, so, and let's see. Still I have a problem for some reason, which is interesting. Is it like a problem with the actual resizing that we're doing, or is it something else? Let's actually comment that out for a second and see. And yeah, it is. So something is wrong with our resize function. Let's see, destroy. Destroying the swap chain, creating a new swap chain. I'm not setting the swap chain images back. Oh my god. Come on. Can't believe this. Right. Now let's see. And we're good. Now, well, apparently that doesn't seem to work though. What the heck? Why? It's not responding. Really? Well, that's strange. What if we remove this device wait idle? Nah, it still doesn't work. What the heck? I'm confused right now. Destroy swap chain. Well, I guess let's do something real quick just to make sure it's not the problem here. Is that we had something called odd swap chain here, which you could pass in. Let's try to use it and see if that would help by any chance. So like extend, and then you could like give it an old swap chain here. Old swap chain, vk, what is it called? Swap chain khr. And yeah, now let's see where we're using this create swap chain, because we're using it in two places. Here we don't have any previous swap chain, so we're just gonna say vk swap chain null, none, null, yeah. The other place is, well, here. And here we do actually have an old swap chain. Right. Wait, let me ask ChatGPT something just to make sure. Should I destroy the swap chain first, then pass it as old swap chain to the new one, or create the new one then destroy the old one? Let's see. The good news though is, like, after we handle all this crap, we don't have to think about it anymore. That's the thing. Greatness about abstractions. So let's see. We just solved the problem once and we forget about it. Create a new swap chain first, pass in the current one in old swap chain, then retire, destroy the old swap chain. So you're done with this image. So create the new swap chain first. Okay, let's do that. And then destroy the old one. And we're getting the new images. Would that help by any chance? Let's see. Whoops. Swap chain invalid vk swap chain khr. Really? Wait a second. Wait. Let me debug this real quick. I think maybe it's been called what? Wait. Really? Weird. I'm so confused. Oh. Damn. Damn. So I'm destroying the news object. Have a good night, Arrestin. Well, thank you so much for coming to the stream. So we need to store the old swap chain handle so we don't destroy the new one. And then here we just destroy the old swap chain. Oh my god. Can't believe this. Alright, so now let's actually debug this. What? Why the heck I still can't resize this? Come on. Really? Bruh. Let me grab the validation layers real quick here. No, let's do this validation. And let's try this out. When I try to resize, it doesn't work. Like, bruh. Let me try maybe the API item so I could see what kind of vulkan functions are being called currently. Something weird happened there. No? Oh yeah, it blocked at here. Reset fences. So let's see what happened here. So in frame 4, we got the new swap chain images. Oh yeah. We shouldn't destroy the swap chain directly. So yeah, I see. That sucks. Alright, well. So here basically what we should really do is mark this for destruction. We should still keep though this resize function honestly, but we should have some other function for marking this as for destruction, which is basically, so instead of resize we're gonna say mark wait, resize size. Yeah, let's call this mark for destruction. Or is it? Honestly, the render shouldn't really care how you do that, so no, let's not do that. Let's just take this whole thing and remove it from here. And the only thing we're gonna keep track of is we're gonna have is the swap chain dirty? If so, And we also need to keep track of the swap chain extent though. Right. Now what we're gonna do, so here when it tell us to resize the window, what we're actually gonna do is say self dot is swap chain dirty is equal to true, and then we're gonna set the swap chain extent to the new size. I don't think we can do that. Well, we're just gonna do it ourselves then. Extend to the dot width size 0 dot height size 1. And here in fact we don't even need a result anymore. And then we need to decide right now where we wanted to check to destroy the swap chain. And honestly, the best place would be in here. After acquiring an image, or in fact maybe even, yeah, after basically waiting for the in-flight fence. And essentially here, acquire image. We also gotta check if it's suboptimal and so on. So we're gonna handle the errors there. So that's cool. So if is swap chain dirty, then we're gonna remake. But what's going on here? Let's remove this OK thing. And there we go. Now another thing here is that, well, actually let's just try this first. Yeah, let's try this first. So here's self dot extend. Well, actually we just use this directly, yeah. Yeah, I believe that's basically what we need to do here. And if we do that, then we're actually gonna return, really. Okay, we want to return from now. Since the image that we just acquired is no longer valid, since we recreated the swap chain, unfortunately. So let's go right now. Also, the image index is no longer valid, so that's cool. Alright, so now let's see what we got other than that. Missing fields, yeah, sure. So at first, the swap chain wouldn't be dirty, of course. And the swap chain extent, it would be set to the extent that we have here. Right. So like swap chain extent is basically equal to this. And there you go. And yeah. Oh boy, that's a lot of crazy stuff. Okay, now let's try this. Yeah, let's remove this thing. We don't need it anymore. I believe we don't need this anymore either. Let's remove this OK. Let's remove this anyhow result. Because it doesn't error anymore, it just marks it for destruction really. If any error happened, it would just happens in the render function, in the redraw. And yeah. Now let's try this out, and hopefully this time it would work, because oh my god, I'm done. Let's see, wait, hold on, let's remove this API dump stuff. Huh. What? Validation? Bruh. Why this is not showing up? Oh, the swap chain gets destroyed? What? Why? Oh yeah. Oh my god, how much vulkans right now I just stepped on. You know why? Well, let's go to the renderer. And here, I'm checking is swap chain dirty, then I'm recreating the swap chain, but I'm not turning back that freaking flag. Is equal to false. It's no longer dirty. Okay, so that's good. Now let's try. Wait. What's wrong now? Since it could fail. I mean, that's kind of true. Though if it fails, like, we have another problem, but it's fine. Now, I'm not sure what's going wrong here. It's probably something so basic again. So here's what's going on. So we're getting the swap chain, and for some reason we're destroying the swap chain. And then getting... Oh my god. So create swap chain, and then it's giving us this. Are we destroying this way? No, we're not. We're destroying an older one. And then we get in the swap chain images. And why stop there? Like, for real, why stop there? Let's see. Swap chain. Let's see what's happening. Okay. So let's go to the renderer. Let's go to the render function. And let's see what's going on. So let's run. So we are hitting the render function. So it's figuring out that the swap chain is dirty, so it's destroying it, and then returning. And we're back again to the render function. And it... Wait, what? I'm pretty sure we set the dash here to swap chain dirty. What? I'm so confused. Uh-huh. But I remember that happened maybe in frame 4. Really? So what the heck, dude? This is wild. This is really wild. Let me see. Render or what? Okay. So right now the swap chain dirty is true. Okay. Continue. The next time it is dirty again. After that it just goes weird. Well, where we're setting the swap chain dirty to true. The only place is the resize function. Here. So is this like being called twice or something, or what? So confused. What if we actually have one window? Because you never know, there could be some weird bug with multiple windows. Well, that's something. And no. Well, we're gonna have a party debug in this. Alright, let's see. I have no clue, because it seems to be switching that on every time. Do you guys have any idea what could be wrong here? I remember there was maybe a way to watch like what kind of changes some variable, I think. I think at watch point, or yeah, there we go. So you could see when the write happens, or any. So here we're setting the swap chain dirty to false. But after that it just goes off. What the heck? I remember also there was some Wayland crap about winits. Let me see. Oh my god, winit examples, or actually the winit documentation, really. Winit documentation. Let's see. Oh yeah, I think pre-present notify. Wait a second, wait a freaking I think maybe I know what's wrong here. Just maybe. Maybe. So if we go to the render, I think, no, like the app, the clear window app, right? The thing is here we're only redrawing when we actually request that. We're not redrawing every single time. Though, does it automatically? I mean, it should be. But, you know, just let's try something interesting here. Which is when we say about to wait. Like, generate about to wait. Where is it? Generate, yeah. about to wait. So here we want to basically request redrawing for all the functions. Or too simply, what we could also do is just like freaking redraw, really. So like instead of doing it here, we could just do it here. In fact, and also just go through all of them and redraw them for now. Let's try that. Oh. Oh. I see. Well, we're gonna cheat here for a bit just to try stuff up. Actually, we can't. God damn. Alright, fine. Fine. Keep that as it that way. So I'm just gonna add a new function, honestly, for graphics. Graphics, and we're gonna basically tell it to. I'm gonna say as like just as ref, and we're gonna tell it to request redraw. Right, and well, of course in wrap, I believe, and then request redraw. So here we're gonna go to here, and then we're gonna have a function called request redraw. Or actually just itself, yeah. And we're gonna go through every single window we have. Well, we could just say window in self.windows.values, and then basically window.request redraw. Oh my god, freak. So my Vulkan code was fine. It was freaking winning. Oh boy, that was wild. So what was wrong here? Because of Wayland. So the thing is, when the window gets resized and destroy the swap chain and recreate it again, for whatever reason, it doesn't request redrawing. I mean, it's supposed to, but it doesn't for whatever reason. And since I'm only like drawing once the window gets a redraw, it doesn't render anything. And since it doesn't render anything, what happens? It doesn't Wayland doesn't render anything if you don't tell it to. Fuck, dude. You can't reason with Wayland. You can only. Oh my god, dude. Oh my god. That was wild. That was wild. Alright, but one thing before we forget, this is actually good anyway. When you're making your own program in language, I kinda did to some degree. Lermog, welcome to live stream, by the way. You could just check out the video that I've talked about before, which is about parser combinators. Yeah, this one. I mean, it's not like a whole programming language, but we kind of just doing at least some parsing of a kind of like a scripting language kind of thing. So you could check that out, though it's not a full language. Maybe someday we could try LLVM and the other craziness of an actual language. But yeah, Holy See Definitive Editions. Yeah, like maybe it's some time, but right now I just want to focus on this at this point. So while we're at it, we need to make sure to see how we could use this pre-present notify for Wayland. So notify the window system before presenting the window. You should call this event to your draw operation, but before you submit the buffer to display or commit your drawings. Doing so will help win it. Properly schedule, make assumptions. Okay, so if I understand this right, that would really suck. Like, where? So before we present, let's go to our render. So if I understand this right, before we present the image, we gotta do that or what? Huh. Well, that sucks because like we don't have access to the window here. Let me ask ChatGPT. See what it's gonna say. Where should I call pre-present notify of when it's here? The thing is, my rendering code doesn't have access to the window. I mean, we could maybe make some callback thing or like closure and nah, dude. Please tell me there's a better way. I mean, it's working fine without it right now, but you never know. And like most engines are probably not doing this correctly. I mean, it's kind of like a new thing for Wayland. And this only applies for Wayland. Thank you, Wayland. Alright, let's see. What happened to ChatGPT? Which lets when it's scheduled throttle redraw requested sanely, especially in Wayland, avoid missed frame callbacks. Your flow maps to acquire. Build submit, then is there any way you can abstract away this Wayland stuff or just ignore it? I don't. If the market share is worth the effort, I'm sure you can get inspired from a wine Wayland compatibility library. In fact, Wayland here is actually abstracted away by Winit, but you still gotta care about this crap, right? That's the thing. Though the lucky thing is that we should just tackle these weird problems just at first. Just at the start, but later on when we're actually gonna, you know, advance in Vulkan stuff like triangle, cube, and so on, we don't really gotta care about this crap anymore. It's like it's just the first time. We're just gonna make this perfect from the start, and afterwards we don't have to care about any of this crap. So have render do everything up to a present token, then the outer loop which does have the window calls, window present. Okay. Gotcha. Yeah, I see what you're talking about, and that honestly makes much more sense, but a lot of programs stay on X11 force Wayland or use X Wayland. Yeah, I see. But I'm using Wayland, so I don't like the market share is me. Alright, so in your event loop on redraw requested, render.render, clear color, and then pre-present notify. Yeah, I'm pretty sure like all current engines are probably mishandling a lot of crap that we've done today, like for real. Because these things are like new changes. Like the validation layers one is a new change, the Wayland thing is a new change, kind of. So in your event loop on redraw requested, pre-present notify here. Okay, inject a pre-present hook. Yeah, that's what I was thinking about, like making a closure here. What do you think, guys? Should we go with a closure, or should we just split our render and present functions? Honestly, think maybe splitting them could be good call here. Yeah. So it also kind of like maps to OpenGL and other APIs where like you have a separate render and present function. So as you can see, it landed around WinIt 0.29 to let WinIt integrate with platform frame scheduling, Wayland frame callbacks, and Windows DWM pacing. Well, it's also about Windows apparently to, I guess, make it more better, I guess. So request redraw and compositor throttling line up with your actual presents. Call it late after GPU work, before present. But wait, after GPU work. Does that mean we have to actually wait for the GPU work too? Nah, that's gonna suck. But wait, submit command buffer doesn't actually wait for the work. If I want that, then I gotta wait on a fence, which would suck. May I ask why you're rewriting Rust? Overdue RG. I answered this question a lot, and welcome to this live stream, by the way. But honestly, I'm just gonna sum it in one answer. I love Rust. That's honestly what can I say without philosophy. You write submit command buffers just in queues. You write submit command buffers just in queues. You absolutely should not stall the GPU with a fence just to call pre-present notify the call to win. CPU sign hint. Canonical ordering is acquire, record. No fence needed here. I'm not sure if like ChatGPT is just hallucinating here, honestly, because from what it said and what I understood so far, I probably need that, which I'm not gonna do that because it's gonna suck. After you draw it, but before. This whole thing sucks. Yeah. Present token split. I mean, okay, fine. Let's see what we could do here. I'm not gonna bother with that logic. I'm not gonna do a fence here. I'm just gonna do what it said, really, which is to basically call pre-present notify somehow here. And for that to happen, what we could do is we could either make this into its own little function, like where we're actually calling render anyways. We're doing it here, apparently. Okay. All right. Well, you know what? We could do that. Fine. We could take this. And basically call, but it's kind of honestly a bit, what can I say, a bit misleading, because whoever calls this render function think that it would wait for the rendering to finish. But I thought dealing with Intel's code is about as bad as it gets until I actually looked into Wayland's. Yeah, dude, that is wild. But let's not philosophize a lot. Let's just do it. Just do it. The sig fault, why? What happened? What was the problem? So here we need like a mutable. Oh, I guess maybe the good news too is that maybe I would, actually I would, yeah. But here we're gonna need the frame, the image index 2, which will basically store really. And yeah. So now we're gonna have our image swap chain. Or just swap chain image index really. Right? I wasn't putting entry into my struct, so dropped and calling vulkan functions from Lloyd the entry after drop is a crash. Yeah, exactly. You gotta make sure. That's why they're in safe, because basically you gotta make sure to enforce those lifetimes yourself. Otherwise, it wouldn't work. In fact, if you check out the unsafe notice of entry, you would actually find that it said that. Like, let me show you. Ash entry. At least these kind of safety kind of guarantees, they are documented in Rust. In C++ though, like, you are on your own. You have no clue about the safety of the thread safety, about the lifetimes, no clue about anything. You just figured it out. So here, if we go, let's see. DL opening native libraries inherently unsafe. The safety guidelines for library new, library apply here. Yeah, there we go. No vulkan functions load directly or indirectly from this entry may be called after it is dropped. This is the safety notice. This is why it's in safe. That's why you need to basically call in safe. When you basically do this in safe block, you're basically telling Rust that you have indeed seen what safety is about. So yeah. In C++ though, you have no in safe block. You just you just wing it. So add field to type render. Well, haven't I? Yes, I did. Swap chain image index. Let's make this U30 size, I guess, or U32. Yeah, okay. And is that it? Well, actually, we need anyhow. Result. And what's else? Well, okay. Well, here's self.image index again. No, we don't need usize here. And yeah, that's basically it. If I approach physics like how Intel does C++, my professor would try to seek us. Oh my god. Physics, crazy stuff. So now we have splitted those functions. Now, also let's add this. Other than that, now let's go and see where we're calling the render function. After that, what we're gonna basically do is, well, first of all, let's grab the renderer. So our renderer is basically this. And then we're just gonna say render.render and then render.present. Probably gonna make it public. Yep. Is that it? Well, of course, this could fail. And there we go. Now between the render and the present, we're gonna say windows dot get. Yeah, I think the ID dot inwrap dot pre-present notify. Particle physics sounds exciting until you realize you are doing numerical approximations all day. Yeah, I've seen about that stuff. So like in graphics, like in game engines, like there's like you just throw the freaking physics correctness out of the gate, right? So you just approximate everything for performance. Otherwise, it's gonna be horribly slow, and even then, you probably wouldn't. You're still approximating stuff. 'Cause if you really want that, probably want to simulate the atoms, which is not an easy task, even for a very tiny thing. But well, that's considering you have figured out all the equations, and in fact, even the equations themselves, like they're just models. They're not really like the real thing. We don't know really how the real thing works. In fact, even our equations are just like models, theories that just works currently for whichever we're doing. You know, good enough. So simulating the entire universe live stream when coded Java. Yeah. Yeah, try getting your pony computer to approximate differential equation in 100%. Yeah, good luck. We're gonna try actually maybe to maybe like use like a physics, integrate physics engine maybe into our game engine at some point. But let's grab a get of cube rendering first. We haven't even touched shaders yet. But this is what was all the fuss about, is this pre-present modify. Basically splitted my render function into a render and a present. And I take the window and just call pre-present notify. The nice thing is that I kind of basically abstracted in my engine the renders and the windows and the GPU, so the user don't have to think about any of this crap, right? It just works. Which is great. And like most engines really don't care about multiple windows really, or it's just ad hoc, just addition after. But in here I actually thought about it from the start, about how I'm gonna do it. The other thing though that I gotta make sure to think about which is handling on like VK on device error. But for that to work, I need to first of all fix my errors to make them use this error instead of anyhow. And that's gonna be another dimension too. If you do decide to do physics, please don't do it like no way. Why? Like what exactly about Unity? And yeah, let's see if there's any change though after we call this pre-present notify. I mean, yeah, we have a window, great. Wait, what the heck? Why? It's still having problems with the resize? Like, bruh. I'm so... Is it like a Wayland thing or... Oh, wait. I forgot one little thing, which is in the render. I don't know how much... Yeah, cargo add rapier, exactly. Rapier is the best. It's the best. So the thing is, like, how much things I forgot today is wild. Like, there's a lot of moving parts when it comes to the crappy swap change stuff and synchronization. It's wild, man. Self swap chain image index. So let's actually come to here, yeah. And let's make sure to set the swap chain image index after we get it. So like, let's say for example, maybe here. Well, actually after we get it here. Let's say self.swapchain image index is, whoops, is equal to image index. And let's add safecast as usize, and there we go. Now this should work. Okay, we have some other problem for whichever reason. Application has already previously acquired what? Images from swap chain. Only 2 are available to be acquired using a timeout. Bruh. What happened? Arch KDE or Fedora KDE? Arch KDE is more bleeding edge. Honestly, both are good as long as you make sure that Fedora, if you have NVIDIA, make sure you have the right driver. And if you're going with Arch, please just go with CacheOS. It downloads the drivers, installs the drivers for you, and it comes with a pretty good defaults. Like the terminal here, I didn't actually, configure it. It just came configured, which is pretty cool. But other than that, for now, I would honestly prefer, especially if you're just coming into, Linux, just install CacheOS. Like, it handles a lot of cool stuff for you. Fedora KDE is also good, as long as you make sure the drivers are installed. Other than that, both are good. Though maybe I would expect Fedora to be more robust. But who knows? But yeah, both are good. The rigid body sucks, soft body is basically asking too much. All physics are inherently not thread safe. For a cast physics, I gotta stop before being... Yeah, that's... I see what you're talking about. So here what's going on. The swap chain. Oh my god, I hate it. Break. So we have a problem here. Is waiting on a semaphore. Well, wait. Go back. Go back. And let's check out the call stack. So it's coming from here. Why? So render finished semaphores. Self.swap chain image index. What is the swap chain image index, by the way? It's 0. Okay. And who's signaling the render finished the render finished semaphores? This guy. Submit command buffers. I mean, that's right. Like, bro, what? Honestly, let's ask ChatGPT and see what's gonna say about this, really. Hello, OG Gearing. Hello, hello. Let's see what ChatGPT would say about this, honestly, before I lose my mind. The nice thing about AI, it doesn't have to read the whole code line by line to actually figure out what's the problem. Like, it just sees the whole thing somehow using matrices. Like, just multiply matrices and there you go, there's the problem. Any docs that I could read to know what is that Vulkan engine? Can't find them on Discord. What do you mean? So the validation error is Vulkan yelling. You ask to wait on a semaphore that one. Okay, so I have two big foot guns apparently. Per image render finished semaphores. You allocate render per swap chain image and pass to both, and the vacate presents as weight. That can go sideways when images are reused across frames, or when you bail early, resize, and still try to God, I see. I see. I told you. Oh my god. I see. Gotcha. Wait a second. So the thing is, I could bail early, and at that point, we're not actually... Oh my god. Well, honestly, I think, you know what? The best solution here, I believe, is probably the... the hook, the callback hook, really. I mean, we could handle this the way that, like, it basically needs to tell us if it rendered a frame or not successfully. And if so, we could present it. So essentially what we really want here is to say a boolean, to return a boolean. And here we return false, which means that we didn't actually, rendered any frame currently. And then here we tell it true, which means that we actually did render a frame successfully. And so what we're gonna do essentially here, we're gonna say, let's see. So if we rendered successfully, then we're gonna present and pre-present notify. This is the big foot gun. How much foot guns I have. Crazy. What else? You know what? Let's try to use what we had before, really, which is render, which is instead of here render finished image index, let's just use the frame index, really. I don't care. I mean, that's what we had, but I've seen some other samples that using it this way for whichever reason. So it's very strange. But anyways, let's just go with that. Render finished semaphores, and here we wait for it. And that's basically it. And that still suck. So semaphore must not be currently signaled. I'm losing it at this point. Like, for real, I'm losing it. Okay. Swap chain dirty, reset defenses. Honestly, let's do this again. And here we're gonna tell it how we're using this. The one thing what is it called? Yeah, here. So instead of swap chain image iter, well, not here, here, we're gonna say instead 0.2. I don't think though it's the problem. Yeah, never. What the heck? Rebuild swap chain image fence? Are you Oh, well, but I don't think that's the problem. I mean, that's valid though. That's valid, I see. But I don't think it's the problem. Handle out of date, suboptimal. Well, I guess we're gonna handle that. Yeah, sure. Right now, resize. I don't know. If OpenAI is so good, where is OpenAI 2? I don't know. Bro is using AI. Hello, Soup Noodles. Welcome to the live stream. Come use AI with Vulkan and fix it. Do it. Try to create like an engine, a Vulkan engine with AI, and you're still not gonna do it. No, I can't just see someone who knows what they're doing. It is called live coding. Okay. And you never really know what you're doing when you're programming. Unless if you're like used to watching perfect tutorials, then that's something else. So you clean directly to the swap chain without frame buffers. Minimal path summary. That's interesting. AI is the new search engine. 100x more useful than Stack Overflow, even though not always 100%. Right, yep. I agree. Now I don't care. Like if AI could replace my job, please do it. But right now I'm not seeing anything that much. It's just barely helping. So either way, let's actually handle these errors fine, just in case if they are really the cause of this. I don't think though it is, but let's see. Oh, by the way, another thing that could be the problem here. Oh yeah. Well, actually no. Wait. Actually, it is. Yeah. What? I don't know. Image fence. So we're waiting on the fence. Then we're setting the fence to something else, which means it should be doing the job, right? But just in case, I'm gonna set it here to none. Just in case. Also, we're doing something new, like the thing is, in my old engine, I wasn't even handling this. It was fine. It was just that the validation message, the new one, was actually so I know what I'm doing, but this is something new I'm doing. I'm experimenting with something new to fix a new error that just popped up in the spec. So, but who cares anyways? Image fence is equal to vacuum fence null. I don't think that's the error because we're setting here, literally setting here this. Yeah, apparently it's not. Now let's actually try to handle this honestly. And yeah, let's handle this. Fine. So basically acquire image. Acquire image. Are we setting the fence right? I think so. Yes. Now let's check this out. So acquire image function, it's acquire next image, it returns a vacay result, right? So here we're gonna return a vacay result instead. Right, import. There we go. Now instead of returning this, we're gonna return that. Okay. And for the present image, the same thing. Gonna return a vacay result bool. Okay. Now let's remove this and remove OK. Henry OST Denbro first stream in a while without any AI usage. Do you prefer not to vibe code? What are you talking about? I don't understand. Okay, let's see what we got here. So we got that out of the way. Now let's actually go back to our renderer here, and let's match on the, what is it called? Weight fences, acquire image. So instead of returning this result, right now we're gonna actually match on it. And let's see what we got. So first of all, we got an error here, and here is, well, so basically an image index is suboptimal. I am using Copilot here, but it's just disabled right now because it was getting a lot of things wrong, so it was very distracting, so I just disable it for now. That's why. Okay, so let's see what we got here. Image index is suboptimal, and we're just gonna basically return this really, if okay. But if we have an error, we're gonna match on that error, I think. Or actually, instead of that, we could just say error vacay error out of date, I think. Oh, actually vacay result out of date khr. So if we get this problem, then we're basically gonna say self.swapchain is dirty is equal to true. Wait, what's going on here? Oh, expected U32 found bool. Gotcha. So like, do I need to return this or what? I think so. I mean, it doesn't matter really, return whichever, I guess. And then also is suboptimal maybe, but like why they, let me see what they did here. Error date, yeah, suboptimal, but here I am already getting suboptimal here, I think. Otherwise we don't care, just return something. doesn't matter. Or actually, no, instead of that, what I'm gonna do, I'm gonna say unreachable. Or unimplemented, or, yeah. Unreachable, really. Yeah, fine. Let's see what we got here now. That's basically it. Now, it is almost 7 a.m. I'm head to bed. Take care, man. I'll take you to Eastern now for sure. Goodbye, Sloppy. Thank you so much for coming in. That was fun. Alright. I'll be live probably tomorrow again. But yeah. Alright, so I think that's pretty much maybe it. And in fact, let me see if we are indeed hitting these areas in the first place. And no, we're not even hitting them, so this doesn't even matter. Bruh. You know what, let me look at something here. Vacay bootstrap example. Let's check out this example right here. And let's check out this, because this is the only one I could find that have, I think, good synchronization. Other than that, just in case, let's also do the same with the presentation actually. So the present image, yes. Now let's just match on that, I believe. Okay, we're getting some Boolean weird thing. And some error. So if it's I mean, honestly, you know what I'm gonna do? I'm just gonna say unreachable. But honestly, that's exactly what that thing is for. Yeah, like for real. It should crash. I mean, that's true, honestly. So let's keep it for now. I mean, I don't think it even matters anyway, so for now at least. So yeah, let's just do this really. Call it a day for now. Now let me ask ChatGPT. What I'm gonna do is I'm gonna ask it what's the difference between this and that. What's the difference between synchronization of this? Well, actually, instead of pasting the whole code, which is gonna be wild, I'm just gonna take this this one. Between the synchronization of this and this. And let's take this one now. Where is the okay, clean up. But where's the render function? There we go. Draw frame. Whoops. Okay, let's see. Let's see. Where they differ? Who is indexed by frame versus by image? You rust. Command buffer semaphores are per frame. You still keep a per image fence map for ownership, the right thing. Present waits on per frame. The C++ command buffers are per image. Command buffers are per image. What? Finished semaphores are present waits on the image's finished semaphore. I mean, let's try that. So the command buffers, instead of this, we're gonna say self. What is it called? Swap chain images dot length here as u32. That's the first thing, and second thing is this render finished semaphores. Gonna go here, right? The other ones though it stay the same for now. And what's next? Now what we're gonna do here basically is swap chain images. Nah, what is it called? Yeah, here we go, render finished. Now instead of frame index, we're gonna go with image index. That's the first thing. Well, as usize. We're gonna do the same thing for this one, which basically waits on the semaphore. But of course, self dot swap chain image index. That's the first thing. The semaphore is there. Hamza Adam, welcome to live stream. It's not more abstracted really. It's the same, like the same binding. I'm using a raw binding of Vulkan, so I still have the same exact control as of C++. Well, at least on Vulkan, but yeah. Anyways, let's see what we got here. The command buffer 2. Where is it? The command buffer. Let's see. So instead of frame index, let's go with the image index. Right. Same thing here. Hold on a second. Please, no way, don't tell me that. No way. Hello, Noah Honchil, welcome to the live stream. How goes the rewrite? Kind of painful. So I basically was trying to, so basically the validation layer of Vulkan kind of had this new message that they just added, right, about the synchronization stuff, which is very hard in Vulkan. And so I'm trying to basically fix that error, and I just like, also Wayland had their own like pre-present notify, which is also quite new. So these two, I'm trying to like debug it and fix it, and oh my god. So it was kind of crazy. But wait a second, like here we have drop. Yeah, I just ended the command buffer, not really submitting. Okay, and then we're submitting. So is there any place else where we're using the command buffer? Not really. So that's good. Now let's try this one instead. And still same problem. Oh my god, I'm out of here. No way. Is that from the rewrite? No, it's a Vulkan thing. It's a Vulkan thing. Not a really Rust or C++ thing in this case. Why I'm getting this error then? Let's see. Not even the AI really figured out any problem there, so what the heck. Oh. Really? Let's see. Oh my god. Okay, so that was the problem all along? Oh my god. Oh my. And resize still doesn't work for some reason. Consume the signal even if you're aborting the frame. Submit a no-op that waits on the acquired symbol so it becomes in signal, then recreate. Consume. Okay, so now it works, but why I did one, but why resize still doesn't work? Though, let's check out something real quick here. API dump, and let's go here. I guess maybe it's actually gets blocked. Yeah, honestly, should probably check this out off stream, really. I have no clue at this point. How often do you stream? I currently try to stream every day. Pretty much. Yeah, I think at this point I'm so tired. I'm just gonna stop the stream here. We pretty much did quite a lot. We kind of abstracted a lot of things. So as you can see, we have our clear color file here, example, and we changed this into a library which could basically be used by other projects and so on. We made a few classes like the command encoder here, the driver, the GPU, the renderer, blah blah. So most of the work that we've done today is just like refactoring, abstraction, and so on. And yeah, honestly, I'll have to see you the next time. We still have some weird issue here that I'm gonna investigate like off stream. If I don't find a solution, then what I'm gonna simply do is just ignore the new validation error and just do whatever the heck I was doing before for synchronization and call it a day. Other than that, thank you all for coming into this crazy stream, and see you in the next one. If you guys have any questions, please let me know before we end it. It is an error. It's an error warning. It's an error. So this error wasn't here before. It was just added late. Just, you know, these days. Wait, let me see. Hold on. Vulkan validation layer. I don't know if I could find it right now. I've seen it before in GitHub. Yeah, I've seen this. I don't know if I can find it. It's definitely somewhere here in issues. Let's see if we can find it. Of course, it's gonna be on WSI. Let me see if AI could find it, honestly. There was a recent change to validation errors, to validation layers, where the in-flight frame setup that tutorials were using and everyone is using actually raise an error now. Can you find the GitHub issue? Let's see. Yeah, I think it's this one. Wait, what? Yeah, it's still open in the tutorial, yeah. There you go, as stated in a recent, there we go. expose the problem that most Vulkan tutorials, also VK Guide and other derivative works of Vulkan tutorial and Vulkan programs, even VK Cube, which is like the official sample, did not correctly make use of semaphores to synchronize presentation. I'm not a Vulkan professor, here's my understanding of the following code, blah blah. So this is the one I'm talking about. Let me actually share with you the link. So this is what I'm trying to fix. Well, that's hilarious. Yeah, this is what I'm trying to fix this whole freaking day, but it just didn't work. So honestly, if I don't figure out a solution like offline off stream, I'm just gonna like go back, and I don't care about this validation error really. I just spent a bunch of time on debugging the GPU deadlock. There we go. I'll be living. I just look at this. So I just spent a bunch of time on debugging the GPU deadlock that didn't give a validation error. There we go. So this is why they added this one. Well, to be fair, I didn't reproduce with validation on unless it turned off a lot of checks, so I can't be sure validation wouldn't have cut it. To summarize the problem, I have a sequence like this, the following, blah, blah, blah. In the next frame, a signal, blah, blah. I believe the problem is basically described here. I need to wait on a fence in VKQ present KHR by VKXC swap chain maintenance 1. I used this extension before, and it actually did work fine with no validation errors. But the problem is, for whatever reason, when I reinstalled my system, I didn't have this extension anymore. Why? I have no clue. Or maybe I've seen it in Windows and thought it was Linux. I don't know. And why I can't wait. So I don't have it, right? So swap chain. What? Maintenance 1. Wait. I have it? I don't think this is the one. Where is it? What? Just imagine how many engines do things wrong. I mean, they're definitely doing it wrong. There's no mistake in that. Because like most, people working on game engines are like working usually just on the higher stacks, like the abstractions, not really the lower ones. They usually don't touch those after it's all set up and done. Most of the time, unless if someone posts an issue. But yeah. Alright, so before recycling, honestly, I may switch to this extension if I get it to work too. But yeah. But as you can see, because of this guy got this deadlock that wasn't caught by this validation error, they added it. When was this key? In March 27, right? And so now we have this problem. But yeah, guys, that was it for this stream. I'm pretty tired at this point of debugging stuff. And see ya in the next one. Goodbye. See you in tomorrow.